We should be live. Testing, making sure that the audio's live. We should be good on the audio source. Let me make sure that the audio source is good here. Can you hear me? Can you hear me? Testing 1, 2, 3. Hopefully we're in the clear. Can you hear me all right? You can hear me, great. That means that you're hearing me through the, no, you can't hear me. No audio? Can't hear, okay. Then I know what to do. I should do this. There we go. Probably you can hear me now. Hopefully we should be good to go. We have our control room set up. We have our, all right. So you guys know what to do, like the live, so we can get this sent out to as many people as possible and we can start having some interesting conversations. Huh? Connection issue. Okay, that was weird, but here we are. Oh, we should clean our monofocals. Our unifocals. Slide, os, het, glitchy. Yeah, it is glitchy. I don't know why. I noticed that too, that it's giving me a connection issue. Why is the live chat? I don't know what that means. What does that mean? What is the... You can hear me all right, right? Is the connection okay? Connection should be fine. Welcome, welcome. Everybody's having a spectacular day. Stop skipping. I'm not trying to skip. I'm so sorry. Very quiet. Okay, there we go. Let's just move my mouth a little bit closer. Should be a little bit better. I'm glad it's working on YouTube. Yeah, I don't know what's going on with the with TikTok right now. No sound detected. There's very much sound detected. I'm gonna restart. I'm gonna end the live and restart the live. It's TikTok being weird. You can still see me on YouTube though. So if you're watching on YouTube, feel free to hop into the YouTube chat. A little quiet but audible. Oh, how is that? That better? I will be restarting the TikTok live in just a moment. But in the meantime, if you think that the Earth is flat and you want to join in on the conversation, feel free to click the link or type the link into the guest box. And we should be having a spectacular time today. We just got to get TikTok started so we can get some people in here. Excellent, much better. All right, well, as long as TikTok isn't glitchy, we can get some people in here and have some interesting conversations. Who would bother trying to prove this topic? Well, you'd be surprised, but there are flat earthers. They really exist. It makes me wildly sad, but it's the real world that we live in. All right, hopefully we're back live again. Let me double check that it's not my computer throttling me. I think we're okay. Still waiting on a model of a flat Earth that can simultaneously map the seasonal progression of the sun and predict sunrise and sunset in both hemispheres. Yeah, it cannot. We all know the Earth is velociraptor shaped. True. Hopefully am I going to be on Red Note? I will be on YouTube. I have a Red Note account, but that's not going to last forever. It'll be banned too. So come join on YouTube. It's better there. Most of your favorite content creators are not going to be going to Red Note because you can't monetize there anyway. All right, we have a guest on TikTok, although I think that this person doesn't believe in a flat Earth. Ah, you have some echo.
I have echo?
I think you're good now. All right, what shape do you think the Earth is, Phoenix?
Oh, it's definitely round.
All right, then why'd you join?
Because I'm trying to figure out how people actually think flat Earth is anything close to real, because there's so much evidence that it's round. It's like overwhelming. So it boggles my mind.
It boggles my mind too, but some people distrust authorities so much, like so overwhelmingly much, that they'd rather think the Earth is flat than, agree with NASA or agree with a science textbook for once.
Okay, well, can I give you a dad joke?
No, get out of here. It is forbidden. Guest super duper quiet. Okay, I'll turn up the guest volume. It was a problem last time, but I'll take care of that. Should probably be better now. Are you tall? Yeah, I'm 7'6" canonically. Yep, it is known. By the way, if you're on TikTok or if you're on YouTube, make sure to like the live stream, so then we can get more people in here and potentially have some good, interesting conversations. In the meantime, happy to talk to chat and answer questions about flat earthers. Is it possible for that to be in only one point in space? I don't know what that means. The answer is that people prioritize intuition over demonstrable evidence when said evidence is counterintuitive. Yes, it's that, but it's also it's just wild distrust, right? That's really what it boils down to. And sometimes that distrust is also paired with religious extremism, which is just a shame and a bummer. But it is what it is. We can't really change anything about that, except convincing them of otherwise. Have you played Marvel Rivals? Yes, I'm working on it. It's a fun game. What's your opinion on the fine-tuned universe? Does that explain God? I don't know if it does. I don't really believe that, no. First time watching you on YouTube. Well, welcome, Vegan Philosophy. We have a guest. But this is a follower, so it's probably not a flat earther. But we'll see. Kaufman, how's it going?
What's good, dude?
What shape do you think the Earth is?
Probably like spherical, or like eggy.
Why'd you join the bot? Why'd you join the guest box?
Cause I'm drinking beer right now, dude. This shit's pretty cool.
All right. Well, Kaufman, enjoy from the comments. Yeah, so flat Earth has been dead. It's actually been dead for a few thousand years, all things considered. And yet still people cling on to it, unfortunately. Yeah, it is also the fact that flat earthers want to be part of some minority that knows something. That's absolutely true. When you are a mediocre person, it feels good to be in a special group. What will be the YouTube equivalent of unleashing the hair? We're going to do it at 100 likes so far. If we can get to 100 likes, then we'll do it. But that requires 100 individual viewers. But we'll see what we can do. Can you talk about skyquakes? I don't think that they're real. Even the Vikings knew it's around. True. All right, we have another guest. Let's bring on another guest.
It's too slow.
Oh, the guest box isn't working. Here we go. We have a guest. Hello. Brandon, how's it going?
Hey man, how you doing?
I'm doing all right. What shape do you think the Earth is?
It's round, but I do have a question for you.
All right, go ahead.
Okay, so I assume the picture that's in your background is the picture from the James Webb telescope?
It is. It is.
And that's showing galaxies, correct?
Yep.
And like all these galaxies would have like their own planets, right?
Yep.
And this is only like a very small fraction of the entire universe itself, right?
Yep.
And there's this many galaxies, right?
Well, there's way more, but yes.
Yeah, nah, I'm just talking about in this picture.
Yeah.
Okay, therefore, do you believe that there's life somewhere else?
Yeah, probably.
Do you think it's probably, or do you think it's guaranteed?
I mean, it's probably, as in a high probability. Yeah.
I mean, when you think about it, all these galaxies, and they all got however many planets in them.
Look, it's just a probability game. Like, it's a very high probability, but it's not guaranteed. Right.
I mean, yeah, I guess it's not guaranteed because we haven't found it yet,
Right.
right?
But look, Brandon,
Okay.
I gotta let you go since you're not opposition, but thanks for being here.
All right. Just wanted your opinion.
Well, you got it. Today is not Ask a Physicist, by the way. It's not the topic today. What's your stance on the shape of the universe? It's flat. Hilariously enough, it's flat. All right, let's talk to Lorelia. Hopefully we get some opposition today. Lorelia, how's it going?
Hello, I'm in German.
Welcome. What shape do you think the Earth is?
Not that picture you've sent in this oh god, stream.
Okay, but what shape do you think it is?
I know we live on a flat sag mal Ebene.
Sorry, one more time?
It's flat, but I don't think it's like this picture on this one.
I know. The picture is
But
a joke. But why do you think the Earth is flat?
yes, okay. Why do you put a picture of joking in this site? That's pump. It's not good.
Well, I mean, I'm making fun of flat Earth because flat Earth is wrong and funny.
Okay, so we make also fun through the globe Earthers.
I mean, you can,
spinning
but
around. And,
I mean, you absolutely can. But the thing is like we have data on our side. So why don't you tell me why you think the Earth is flat?
where's the start from the galaxy or for the universe?
Where's the start? I don't know what you mean by that question. Do you mean like when did it start?
When did it start? With what material?
What material? I mean, the universe is made of mostly hydrogen.
The universe is starting with nothing.
Well, I don't
Okay.
believe that.
How is this possible?
Well, I don't believe that.
Okay, so tell me, how does it works with the globe Earth in the universe with this, wie sagt man das? Mehreren Geschwindigkeiten, multiple speeds. Okay. How does it works? With
How does a
multiple-
globe work? Well, the globe is roughly globe-shaped. It's like a sphere. It's made of rock. It's held together by gravity,
Okay.
and it
Inside
orbits
the globe?
things. What do you mean inside the globe?
What's inside the globe?
I mean, there's a bunch of rock, there's some water, there's a lot of metal, some air.
Okay. Some air inside the globe, eh?
Well, I mean, the globe includes the atmosphere, right?
Okay, that's the atmosphere. But the atmosphere, the last two layers are helium and water. Wie sagt man das? Hydrogen.
Well, it's not, I mean, the layers aren't divided by what they're made out of. The layers are divided by things like temperature and density, electrical conductivity, and things like that. But yeah, I mean, like, yes, it is true that that lighter gases tend to be higher. Why don't you tell me why you think the Earth is flat?
There are enough experiences with, wie sagt man, Erdkrummung. With the round.
Sorry, can you repeat that? Your audio is not that great.
Yes, I know that's not great. It's better for me to speak in German, but not.
I understand.
I'm not good in English. With writing is better. I can take Google for the translation and so. Okay, the Earth, the last atmospheric layers are helium and hydrogen.
Well, I mean, that's not really true.
Why? It was told by the scientists.
But, I mean, okay, let's say that's true. I asked you why you believe the Earth is flat.
Why?
Yeah, why? Why do you think it's flat?
Okay. Water is flat.
Water is flat? Have you ever seen like a water droplet?
Water drop is little, wie sagt man, Spannung? It's too small, and
But it's not flat, is it?
Yes, it's not flat.
So
It's
what?
true, yes.
So when you say water is flat, it's wrong, right? Like there is water that's not flat.
You put apples and pineapples all together. That's not correct for you.
I mean,
That's
but
not
so
science.
how big does it how big does it have to be for you to consider it to be not flat? If a water droplet
We
is too
have
small, how big would it have to be?
okay. We have different groundings with sand, with rocks, with wie sagt man dann? Wie kommt man auf diesen Klippen? Ja, genau, Klippen. And the water was broken on every Grenze. Where the water is reached the groundings with the sand and so on and so on. There is no possibility to keep the Spannung like a water drop. Spannung.
My point is that water drops are round, they're like curved because of forces. And the water on the Earth, on the globe, is curved because of a force, gravity.
Gravity is a theory, and
No, it's not. It's a law.
It's not a lot.
Sure it is.
It's a funny law. It's a very funny lie law.
I mean, it's called
I mean
Newton's
it-
universal law of gravitation.
No, that's wie sagt man, Maskottchen. Newton, Einstein, those are thumb mascots. They are thumb. They were presented for people like you and others to believe that bullshit. Okay.
How do you know? So why is it that we're able to do experiments that prove that gravity is real? By the way, Grugtar, thank you for the galaxy. I appreciate you.
And the vacuum chamber and the feather and sagt man Gewicht? In a vacuum chamber.
Mm-hmm.
A feather and 1 kilo material
Sure.
is rounding. Sag mal zeitgleich. Schreib's rein. Übersetzt mal. Zeitgleich. On the same time. Okay.
Yeah, so you drop them both at the same time,
Yes.
and they fall.
because-
But that's not the
Yes.
only way that we can prove gravity is real. We have plenty
No,
of experiments.
Okay, then tell me.
Yeah, so
Electricity?
have you heard about the Cavendish experiment?
Carpentish.
Cavendish, 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 named after an Englishman. Are you familiar?
Tell me about this.
So essentially, you take two heavy balls, you connect them by a rod, and then you hang it from the
Okay.
ceiling with a very thin string. Do you know it?
But you don't
So
do that.
you take two heavy balls, you connect them by a rod, and then you hang it from a string so it can spin, right? Then you take two other heavy balls and put them so that if there is an attraction between each pair of balls, then the whole thing will spin. It'll rotate. And you can do this in like your garage or your basement, and you can measure the spin, the gravitational attraction, between the two heavy masses. It's pretty easy to do.
Okay, so I have to know, is the string where the balls are they drifted? Wie sagt man? Moment. Ich glaube, es wird.
Are you asking if they're magnetic?
Did the strings where the balls were fixed on? If the strings drilled.
Are the strings what? I'm sorry.
Are the strings drilled where the balls are fixed on?
Are the strings drilled?
Yes.
I mean, you can attach them however you want. By the way, the experiment looks something like this. This is what the apparatus looks like.
Okay. Did you make this experience?
Yes, I've done it myself. I have done it, and I've seen other people do it.
Okay. And you have visualization like that?
I did it more than 10 years ago, so no. But I can show you a video if you want, or like there's plenty of videos of people doing this.
And I know you do this without an ideology or without money for doing that to represent a believing.
You can do it yourself. It's very easy to do. It doesn't cost very much to do. Maybe, I don't know, 50 euros.
Yes, but which drill does it have?
Which drill? I don't understand.
Drilled like left side, right side.
Oh, it'll go. The masses attract each other, right? So it'll spin. It'll spin in the direction so that the masses get closer to each other. I can put it back up if you want. So the red ball goes towards the closer gray ball on both sides, so the whole thing spins.
This is the mass where the other balls fixed.
Yeah, they're just like on the ground.
On the ground. Okay.
Yeah, you can put them on the ground if you want. You could put them wherever you want. It doesn't matter.
That's error on this. The big balls, great M's on the ground.
Yep.
Okay, tell me how the ground is electrified. And
well, so you can do this experiment with both metals and with non-conducting materials. So the electric field doesn't play a role.
Put the greater M's into the same air layers.
Into the same what?
And we put the greater M's on the same air layers.
Yeah, you can do that.
Yes, you have to do that.
No, that's how it's typically done. By the way, it's typically done in a vacuum. And it's done with just like suspensions. But if you want to do it in your garage or your basement, then you'd probably just put it on the ground because it's easiest.
You have to put this greater amps in the same conditions like the smaller amps.
They are in the same conditions. They're both at the same height.
Not the conditions like
you can
vacuum.
suspend you can put them both in a vacuum. You can suspend them from strings, whatever you want. The same thing happens.
Do you think that's correct?
Yes,
Then
yes, there are videos of this.
Okay. You use the same material.
You can use whatever materials you want. You get the same effect.
You have to use the same materials for the greater amps and the smaller amps.
No, you don't. You can use whatever materials you want.
and you have to use also the other fixed materials on the other M's.
So you can use whatever materials you want, but yeah, you can use the same ones. You can also use different ones, and you'll get the exact same thing.
You have to do the same conditions, okay? And also you have, wie sagt man, Reibung.
Go ahead.
They are fixed in fix it on one string. Okay?
I mean, the point is, like, I don't see how that's relevant to the experiment.
But
The point is
this
that
what-
we can, like, you can see the image, right?
Did you know that that's only a position drifting? It's that
Why does this
told
happen?
nothing about the gravity.
But why does this happen?
Only that's the electricity.
Why does this happen? Because you can shield it
the
from electric
rotation
fields. You can shield it from electric fields. You can shield it from magnetism. You can shield it from vibration. You can do the whole thing in a vacuum chamber. You can remove
You
excess
can't
material around. You can
shield-
all of this has been done.
You can't shield magnetism.
Sure, you can use a Faraday cage.
No, you can't.
Sure, you can. You absolutely can.
How?
You can use a
Where
Faraday.
did you
can use
told us?
you can use a Faraday cage, or you can use or you can build other
Where
magnets
you
that
told us
counteract.
You can do. Put
Yeah, so
the
this
magnetism,
you
away.
you learn this.
What's wrong with you?
You learn this at university. This is a thing that you can really do.
Oh, you learn it in a university. Whoa,
Yeah.
no, that's not correct. That's please don't.
So can you tell me what magnetism is?
Yes, what can I do with English words? Das ist eine natürliche Anziehungskraft.
Sorry?
Mit Reibung hat es nichts zu tun. Wie kann man das noch sagen? Elektrostatik und so weiter. Auch das. Verdammte Axt. Wie soll man das jetzt so auf Englisch erklären? Die Eigenschaft eines.
Guys, have some grace. English isn't her first language, and she's doing great. So be nice, okay?
Not easy to told it in English.
Of course, Lorelia, I applaud you for having this conversation in a language that isn't your mother tongue. Like it's impressive regardless.
We can't, wie sagt man, isolate magnetism.
We can't. Why do you think so?
It's not possible.
Why not? I mean, so if you make if you know the magnetic field at a place, why can't you just make another magnet that counteracts it?
It is a natural essence inside every material. Okay.
You can definitely block. You can definitely block magnets.
We stand on the material, and why can you put the conditions without contact of the ground?
Here, let me help.
You have to do this experience in the air without contact on the ground.
So I don't know if you can see this, but so let's go take a look at what it says further down if we can scroll. Hold on, let me just pull up the actual website rather than window capture test. One sec. Here we go. So if you can you see this? Talking about
Yes.
shielding from magnetic fields. So it says the best material for magnetic shielding is any ferromagnetic material. You can shield. You can redirect the lines to go around something.
So you shield it with the
Yeah.
ferromagnetics, and
Yeah.
every single material does have its own electricity. Electricity.
Yeah, you can block that too.
Unblock that.
Yeah, you can block it with any sort of conducting material between the two things.
Then it doesn't work.
Why not? I mean, like, this is a thing that's well documented. I can show you a paper for it. Let me pull up a resource for you. Let me see if I can find it. It's in my notes. And here we go. Let's pull this up. There we go. Hopefully you can see this. Make it a little bit bigger. So here, this is a measurement of gravitational coupling between millimeter-sized masses, and they go through all of the details of inducing shielding. So in particular, they do things like, let me see if I can find it. They put it in a vacuum, they did vibration isolation, they did some source stuff. They measured the charge so that they can model the electromagnetic force. They used an electrostatic shield to prevent the electric force causing the attraction between two things.
Okay.
They eliminated seismic noise. They eliminated magnetic coupling. They dealt with magnetic interactions. They dealt with the like. This is all fairly straightforward stuff.
With the ground?
What interaction with the ground? Are you talking about, like, the gravity?
No.
What interaction with the ground?
Which you walking about? Where you're walking? The ground.
Yeah, so there's a force pushing you up and a force pulling you down. The force pulling you down is gravity. The force pushing you up is roughly, it's called the normal force.
Gravity is density.
Density isn't a force, though.
It's also included, I know, yes.
Well, density is not a force, right? I mean, look, it's just a fact that if you take two things and you put them near each other, there's a force between them. And you can eliminate all of the other possibilities. You can eliminate electrostatics, you can eliminate magnetism, you can eliminate air currents, you can eliminate pressure, you can eliminate seismic noise, you can eliminate vibrations, and you're still left with a force.
But you can't eliminate the contact to the ground where you're walking on.
Well, so the experiment that I just showed you, the whole thing was hanging. It was all isolated from the ground using seismic or using vibrational isolation. Sorry?
And the whole thing is hanging, is contacted with the ground.
I actually don't think that they're contacted with the ground in this experiment, because they have it vibrationally isolated.
You see it hanging.
They're using. I can show
You
you.
only have the eyes on the experience, but you don't have the eyes on the experience where it's
The
hanging
vacuum
on.
chamber is placed on an optical table. It's not in contact with the ground. So the vacuum chamber is placed on an optical table with deflated air springs, which means that it's actually not touching the ground at all. There's an air gap between the table and the ground.
Where is the table with the isolation station? Put it on.
Do you want a picture? I don't actually know if they have a picture of their setup. You want like a photograph? Or they might. Let me scroll up and see if I can find it.
Inside a room, and it flies inside the room.
No, it's not flying.
Contact on the ground.
It's not flying. It's on an air. Do you know what an air spring is?
This is one point.
Do you know what an air spring is? Do you know what an air spring is?
Nope.
So an air spring is basically a tube that has, it's like a piston, like a piston in an engine. Let me see if I can find a diagram. One moment. See if I can find like a diagram rather than just Okay, there are no good diagrams for this that are not like actual mechanical diagrams. But, sorry, I have to sneeze. So, thank you. So an air spring is basically just like a piston that has air between the bottom and the top, and so when there's a force pushing the piston down, the air pressure keeps it up.
Okay. It's
So
inside.
there's actually like a gap. There's actually like a gap.
So you can isolate it with
From the ground. Yeah.
with Perma-Eis. Wie sagt man das?
Yeah, you can isolate it from the ground, you can isolate it from the air using a vacuum, you can isolate it from magnetic fields using magnetic shielding, you can isolate it from electrostatic fields using an electrostatic shield.
I like to isolate it from the contact to the ground. There's no touch to the ground.
Yeah, they used air springs.
You know what I mean.
They said that they used air springs.
They use air springs. How does it work? If you isolate it with the air, and you put air springs inside, that's not working.
Why doesn't it
You
work?
isolate from air.
Why wouldn't that work?
You say you isolate it from air.
Yeah,
and
you can. So the table is on an air spring, and then on the table is the vacuum chamber. So they isolate the vacuum chamber from air because there's no air in the vacuum chamber. And then the whole table itself is isolated from the ground with the air springs.
The touch is inside the material from the vacuum chamber. There's also material.
Yes, the vacuum chamber is made of material, but they didn't make it. They made everything without ferromagnetic materials, so that there's no accidental magnetic fields between them.
You can't isolate any possibilities to make a sign experience 100% perfectly.
Okay, so if you don't think that it can be done perfectly, then why do you think that they didn't do as good as well as you can? I mean, they accounted for any stray magnetic forces, any stray electromagnetic forces, and there was still an effect even on top of those. So, like, I mean, it just sounds like you're just saying, "Nuh-uh, you're wrong. This is impossible," even though you haven't read the paper to actually check to see how the experiment was done. By the way, I would recommend anybody read it. It's a fairly straightforward read, and it's a fairly short paper. Absolutely would recommend everybody reading this. It's a good paper. And it's a great example of how to do good physics experiments. So would recommend. But like, I mean, it's easy to say, no, the experiment was wrong when you haven't actually looked at the experiment yourself.
But you can also misinterpretieren.
So why not go read the paper and then tell me where they made a mistake? Rather than just guessing, why not go read it and tell me where they made a mistake?
You can give me a personal message and I read it.
You should just take, oops, that's not what I wanted to show you. You should just take a screenshot and then you should be able to find it just by typing in the name of the title.
I have a small Moment.
Oh, where'd she go? You should just take a screenshot.
Okay, and I gave me. I follow you.
Okay.
Next time, I hope I have a better English in this.
Lorelia,
When
honestly,
I write, when
your
I can
English...
write, I have time. My
I know,
English
I know.
to speak is not as well.
Lorelia, your
But,
English is better than my German. Don't feel bad, okay?
It's okay.
You did great. All right, good luck, and I'll see you next time, okay?
Okay.
All right, let's bring up another guest from TikTok. By the way, we have super chats. Thank you, Ethan. Was that Ethan that? Yeah. Oh, no, it was Econo NYC. Thank you, Econo NYC, for the super chat. We have those now. Let's bring up a guest. Let's bring up Top Sport.
Hey, thank you, Blitz. I appreciate.
Welcome, welcome. What shape do you believe the Earth is?
The Earth is actually, the shape is geo, if you know what geo is.
Do you mean geoid?
So the Earth is a geo. Yes, geo.
Okay.
Circle.
So then we agree.
Yes.
We agree. And this is
Oh, thank you. Okay,
this
so
is for opposition.
does
Thank
a
you for being
circle
here.
mean?
He said it's a geoid, right? Or was I just misunderstanding him?
Dr. Blitz was good.
Welcome, welcome.
Yo, Dr. Blitz, you remember me though?
I don't. What shape do you think the Earth is?
Yeah. So I think the Earth is flat. But before I start like the argument with you, yeah, you remember the argument with the time with like the necessary existence of God and stuff. Where like I was.
I have that. I have. Oh yeah. Well, I remember a guy, but yeah, I have a bunch of arguments with people who try to run the ontological argument. So.
And I was eating almonds, making you know me, bro. You know me. Come on.
Okay. Okay. Anyway, so you think the Earth is flat? You think the Earth is flat?
Yeah, I think the Earth is flat.
Okay.
Yeah.
Why do you think so?
Yeah, just let me get my earphones in again, so like I can just give me like a.
Sure thing. By the way, y'all, if you're watching from YouTube, make sure to like the live. And if you're watching from TikTok, make sure to tap the screen and like the live. And if you want to support me, there's a Discord, there's a Cash App, all these lovely things.
Dr. Blitz, what's your thoughts on looks maxing?
You should do more. You should do more of these, what is it called, mewing, so you can get this kind of jawline.
Bro, you actually believe in those? Tripping.
No, bro, I'm trolling you. I just have a naturally good jawline, okay?
Sure, bro. Sure. Let's argue on this topic because Okay, so I will take the argument that the Earth is flat. Yes.
Do you actually believe the Earth is flat?
Yeah. Sure.
I don't believe you. I don't believe that you believe that. Sorry.
Okay. So, but the thing is.
All right, let's bring up another guest. Come on. Oh, Top Sport's back in the box. Maybe I just misunderstood.
Okay, you just misunderstood me, bro.
Oh, I
This
must have.
time I
Okay.
don't know what's going on.
So do you think the Earth
Yeah.
is flat?
So the Earth is flat.
Okay,
Yes,
you think
it
the
is.
Earth is flat. Why so?
Why so? Because we say that we observe that the Earth doesn't move, that the Earth how can I say this? Have a circle, have a barrier. It's also the how can I say that? The cosmology, it proves that the Earth is also a circle. You know what
Okay,
I'm
so
saying?
what's
that's
the
what
evidence?
I mean with the geo.
What's the evidence for this? What's the evidence of the cosmology proving the Earth is a circle?
Okay, the cosmic and the tropics, they all circle around the Earth. You know what I'm saying? Above the Earth, I mean. So it shows
Well, yeah,
up how
they
the
rotate.
Earth looks
Sure.
like.
Yeah, they rotate around the Earth. Sure.
In your view, is rotating, but in our view, is like circling above the Earth.
Can you explain why stars rotate in one direction in the northern hemisphere and in another direction in the southern hemisphere?
Oh, exactly, that's a good point.
Yeah,
that's great. That's great.
How does that work on a flat Earth?
Great. That's a great question, but take your time. I have good evidence, my friend. Don't worry. Just
Okay. I
have
want
to
the
explain.
good evidence.
So great. Okay, great. So last time we talked about the glass or the solid matter or the crystal which can create reflection and refraction. That's one. So this matter or this solid matter which create the stars of southern hemisphere and the north hemisphere going in different circles, in clockwise and anti-clockwise. But
why do they go in
in
different directions?
Because of the solid matter which convex. The convex, bro, that's a convex. We have a convex solid matter, and which is the firmament.
Why would that make it go in one direction?
Two different reactions.
Why would that make it go in one direction? And another question. I was just about to bring this up, Aija. Why is it that they go in a straight line at the equator? They don't rotate at all. They just go in a straight line above you.
Yeah, because that's because of the shape of the convex. And the
Okay,
equator,
So what convex shape would allow for one direction rotation clockwise? Sorry, for one place for you to observe clockwise rotation, another place for you to observe counterclockwise rotation, and a third place where you observe no rotation at all. What kind of shape would give you that?
No rotation.
So at the equator, it doesn't there's no circular motion. It just goes straight overhead.
Yes, that's just because the equator represents the center of the Earth.
Oh, so wait a minute.
That's it.
The equator is the center, like on a globe?
In both models, on a globe and in a flat Earth.
Wait, how is it the center on a flat Earth? On a flat Earth, the equator is not. The equator is halfway out, but it doesn't represent half the size of the Earth. It's not like half the area is inside and half the area is outside.
Okay, my friend. When I say the center, I mean the center of the tropics. We have Capricorn and we have Arctic Circle.
Why does that affect the?
Exactly.
Why does that affect the rotation? Why does that affect the lack thereof of rotation of stars directly overhead?
Great. Now we have the convex solid matter which create refractions. You can't just say
convex. You can't just say convex creates refractions and then use that to wipe away any explanation. You actually have to explain where the actual thing is that's doing the refracting and what the shape of the thing is that is causing the refraction. You actually have to explain that and show that it works. It's not enough to just say it's refraction and then, brush it off. Like, you actually have work to do.
Okay, if you search for a convex glass or glass or crystal, this solid or this matter create the refraction.
Okay, what's the material made out of?
You can do your own experiment.
What's the material made out of?
I say crystal.
What kind of crystal? What's the index of refraction? Thank you for the $5 on YouTube. IMS Fox. IMS the Fox. I appreciate you. What's the index of refraction made out of? Or sorry, what is the index of refraction of the material? So how can you say it's caused by refraction when, in order to know what kind of refraction happens, you have to know what the index of refraction is?
Yeah, but you can search for a convex lens. This convex lens, it shows you up how can things be reflected or refractions. You know what I'm saying? You can do your own experiments on this. You can look it up.
But how do we know that actually applies to our world, right? Because we don't even know. Let's say the firmament is real. What is it made out of? We need to know the index of refraction. Where are the actual stars? Are they above the index? Are they above the firmament? Are they below the firmament and then reflecting? What's causing this light?
Exactly. That's okay. Great. Now you're asking good questions.
No. I'm sorry. Don't say exactly. This is a question that you have to answer.
Okay, great. I'm saying it. That's the most people or flat earthers saying that the sun and the moon, they are inside the firmament. This is wrong. That's what I'm saying. The cosmic tree is above the firmament, which all planets rotating. Planets and the stars. Stars mean a zodiac. Stars are all in the Ziva heavens. So our firmament that we are talking about, that which create many reflections or create light density, it's all in the first firmament. It's in the first heaven.
So you have a problem here, because if it's the case that the sun and the moon and the stars are above the firmament, and the firmament is a refractive dome, then both the sun, the moon, and the stars should be smeared out. They shouldn't appear as perfect circles or points of light.
No, that's no the lens. The only what the word for the lens is just reflecting stuff.
Any curved
make it shape.
Any curved media or any curved change in medium will cause distortions unless the thing is perfectly spherical and the thing that's causing the distortion is at the center. But the sun is not always at the center. It's not always directly above the North Pole in your model. It moves, so it will always appear distorted.
Exactly.
Oh, so you agree?
No, but no, we. Yeah, I agree, but we observe different seasons.
Why does the sun always feel like? Why does the sun always appear to be the same shape?
Just because of the refraction. The refraction
would
make it bigger or smaller.
It would make it change shape. Like it would be like this shape or like this shape, or it would be bigger or smaller. It absolutely would. Yeah.
We have you can.
That's how optics
do
works.
Your own experiments on this.
I've taught optics before. You know I've taught optics before, right? I've run these experiments so many times.
Why we cannot talk about the moon? But it does maybe.
We can talk about the moon if you want.
But it depends. It depends. The moon is also changed its size.
Yeah, but it's never distorted. It's never distorted. It's never distorted, which it should be under your model.
You proving. No, bro, you prove it. I didn't ask that. You should ask that the sun or the moon changing its size.
No, shape. It changes its shape. That's what I care about.
Yeah,
the shape.
Shape.
It won't be a circle.
I've never seen a moon.
You're right, and it should happen on your model. It should happen. If the sun or the moon is not directly above the North Pole, then you should see shape distortions because the object that's causing the refraction isn't centered on the lens system.
I agree. I see what you mean, but it doesn't change its shape, but it changes its size.
Yes, it does. Yeah. It absolutely does.
It doesn't change. Just
look at the stars behind me. That's what happens when you have refraction. In this case, it's gravitational refraction. They get smeared out. Like,
okay,
look at this. That's a smeared out galaxy, and that happens because of refraction.
Oh no, bro! Please, I don't like.
Now,
that. Okay.
I know. Evidence is scary. I know evidence is scary. So why don't you tell me why we can measure the rotation of it is. Why don't you tell me why we can measure the rotation of the Earth?
Measure the rotation of the Earth. You measure the rotation of the sun. Not the rotation of the sun. Why can we measure the rotation of the Earth? It has nothing to do with the sky. We can just measure it on the ground. Bro, how you can measure this? Wait, check this out. How you can measure the rotation of the Earth if you know that the sun have different speed in different tropics?
This has nothing to do with the sun.
What I'm saying?
This has nothing to do with the sun. I'm talking about the rotation of the Earth. No, it doesn't.
Okay, bro, the sun of Antarctica is not the same the sun of Arctic Circle.
I'm not talking about the sun at all. Why are we talking about the sun?
Yeah, but we observe other things. How you can just talk about only one topic, bro? We have many topics that we can talk about.
We can. I'm asking you. Hey, chill, okay? I'm asking you, why is it that we can go into the basement of a building and we can measure the rotation of the Earth without involving the sun or the sky at all? Why can we do that?
I say again, I'm sorry.
Why is it that we can go into the basement of a building, like go underground, the sky isn't visible, and you can measure the rotation of the Earth? Why can you do that?
I don't know, bro. Did you measure that before or something?
Yeah, there is a demonstration of this in the one that I was doing was on the first floor rather than underground, but you can do it wherever you want. It doesn't matter what floor you're on. The point is that you can do this in 3 different ways. You can use a gyroscope, you can use a pendulum, or you can use a Compton generator. None of these require looking at the sky.
Yeah, but you should also tell us what is the sun exactly on Earth, because the sun is different in the different tropics.
That has nothing to do with measuring the rotation of the Earth.
Okay, so it depends on the sun, bro.
No,
It
why
depends
would
on
it?
the
Why would
light,
it?
if there is
Why
some
would it?
light.
You can do it in a dark room. Why do you
I
think?
don't know
Why do you
what this.
like? You can do it inside. Why would the sun play a role?
But the Earth does move, bro. How you can measure something like that?
You can measure the
Only
motion.
if
You can measure the
if you
rotation
steal
of the
some
Earth.
informations.
No. You can measure the rotation of the Earth because the Earth is spinning rather than just moving in a straight direction. You can actually measure it being non-inertial, meaning you can measure in the same way that you can feel the motion of a like if you're on a merry-go-round, you can feel it pulling
Okay.
you out. You can measure that kind of
That's
non-inertial
nice.
motion. So why can we measure that?
Okay, the problem is, you're using only one topic and you're talking only about the rotation of the Earth, and you
We can
don't
talk about other
about
stuff. Why
the
could they see the
other-
sun in Antarctica for
Yeah, but
24
that
hours?
is no. We can no. I don't mean that. I mean that is
Well,
three
but you
different
can.
directions of the
You
Earth.
you
If the
can see
Earth-
the sun in Antarctica
Bro, that is
for 24 hours.
okay. Do you know that the Earth, is not rotation, but it goes in a straight line?
No,
you
it
know,
definitely
in a
rotates.
6,000, 600.
No, it definitely rotates.
It's the speed of light.
What are you
Yeah,
talking about?
that's what
Thank
I
you,
thought.
Ethan,
That's
for the
three
galaxy. I
different
appreciate you.
directions.
The Earth rotates. That's an indisputable fact. We can measure it.
Yeah, okay, that's one. But
Okay,
the
so
second
do you
speed,
do you,
the
wait?
second
I'm sorry.
rotation.
Before we move on, do you agree that the Earth rotates?
No. Of
Okay,
course
so
not.
then let's not move on. Why do you disagree?
I just said we have different seasons. Exactly, like we have different seasons.
What do the
So how you
seasons
can
have to do
measure
with
the Earth?
what do the seasons have to do with the rotation of the Earth? Measuring the rotation of the Earth.
Because the Earth is tilting. The Earth is tilting at the time. In
What
your
does that have to do
perspective.
with the Earth's rotation?
So how you? Because that is different rotations.
No, it doesn't have any.
So how you can measure
Wait,
only
I'm
one?
sorry. The seasons have nothing to do with the rotation of the Earth.
Bro,
You would
yes,
have-
it
you would
does,
ha- you would
because
have
we
seasons-
measure it because of the sunlight.
You would have seasons even if the Earth didn't rotate.
Okay, we can move to other because
Okay.
on this it's too much.
Okay.
Yeah,
Why can you
because
see
the
it?
sun,
Why
you
can
said
you see the
of
sun?
Antarctica.
Yeah. Why can you see the sun for 24 hours in Antarctica?
Why we cannot see the sun?
No.
for
Why
20
can you?
hours? Because
You can see it for 24 hours in a row in Antarctica.
okay, I think you showed me last time a video, yeah,
Yep.
of Antarctica, but
Probably.
the sun, you shows yes, okay, it's okay. We can say yes, that is a 24 hours of a sunlight.
Yep.
But the problem is the sun of Antarctica. It doesn't go in straight line above the horizon.
Nobody
It doesn't
claimed that
do
it goes in a straight line.
It bounce,
Nobody claimed
It's
that.
like bouncing.
Yeah. Nobody claimed the globe model doesn't claim that it should go
Bro,
in a
you
straight
show the
line.
video, bro.
Yeah, I know. It's not supposed to go in a straight line. It goes up
You
and down.
can show the
It just
video
doesn't set.
again, bro. Can you show the video again?
No, I mean I can,
No,
but
but
you
in
know the video I'm
Antarctica,
talking about,
okay.
right? You know the video I'm talking about, right? We watched it together.
Exactly, yeah.
So the sun never
Yes.
sets. It just goes up and down around. That's exactly what you would expect on a globe.
Okay, that's nice. That's very nice. But in Arctic Circle, in North Pole, it goes
does
in
the
a
same thing.
straight line
No, it
above.
doesn't.
No, but it doesn't bounce, I swear.
Sure it does.
doesn't.
It sure
Only-
does.
Wait, do you know what? Do you know what happened, bro? I did my research too, bro. Come on. I can explain, please? Look, when
Hold
I
on.
did my
I'm
research...
pulling up a video.
And I tried... Okay, please. Because, yeah, I want to say the video first. Yeah, like, go ahead.
This is a 360 view, I think. No, it's a 12. This is a 12-hour view. You probably don't won't like that. Summer solstice, midnight sun,
No, I think
24-hour
the video
daylight.
that you showed me last time, that's a new
That-
video of Antarctica. So that's a
No,
good
no,
video.
I know. I'm showing you one of the Arctic,
Ah, yeah.
just so then we can compare, right? So this is. Let me just pull this up really quick. So this is in Alaska. It's in the northern part of Alaska.
Okay.
Let me just play it really quick. So notice the sun's over there. It's going down, but it's not actually setting. It's going to go down. It's going to be close to the horizon. It's going to hang out there for a while. It's very close to the horizon now, but it's not below the horizon, right?
And then raise it again.
And then it's going to rise again. Yep. That's exactly what happens in the Arctic. See how it's rising?
Okay. Can you explain what happened here?
Well,
Okay,
I just proved you wrong.
You cannot see it like that.
I just proved you wrong. You absolutely can.
No. Okay, wait. Okay. Can you explain? Can you talk about this video, please? Maybe
I mean, you
people
can
are
absolutely
listening
try,
too,
yeah.
You know what I mean? They want to see why and why and why. Yes, I'm gonna try. Thank you. So look, here in Arctic Circle or Alaska, the sun, when it's above the Tropic of Cancer, exactly above the Tropic of Cancer, the sun doesn't do this movement. Okay, but if the sun moves again back between Tropic of Cancer and equator, just a bit, yeah, just maybe for a few grads, it can create this effect of going down and then rise again. Do you see what I'm saying? So the Tropic of Cancer, if the sun is exactly above the Tropic of Cancer.
So you know that the sun is only above the Tropic of Cancer for 1 day a year. It's also only above the Tropic of Capricorn for 1 day a year. The video I showed you of Antarctica with the 24-hour sun was taken when the sun was not over the Tropic of Capricorn. The video I just showed you in Alaska was taken when the sun was not over the Tropic of Cancer. So we see the same thing happening in both places. The sun is not directly over the tropic, and we see the sun goes up and then down, and then up and then down, but it never sets. So the exact same thing happens in the north and in the south.
Do that.
It does. I just showed you a video.
No, it doesn't. You just say that.
Do you want me to show you another video?
People cannot see the difference that you're talking about.
Here, let me show you another video. Here's another one.
Yeah, this is Antarctica, I think.
No, this is Arctic. This is in like Sweden.
Okay.
This is actually not even close to the summer solstice.
April. See, that's April,
yeah.
bro. That's
yeah,
April.
yeah.
I'm talking about Yuli, man.
Wait, you know that why?
I'm talking about Yuli.
Why does it matter?
Yuli, give me Yuli, man, please.
Why not April? Wait, why not April? Why not April? Why not April?
Because April. Okay, it's in April. It's not exactly Tropic of Cancer.
It's not exactly the tropic. No. It's over the tropic. It's over the Tropic of Cancer for exactly 1 day a year, and it's in June. It's only for 1 day a year. It's on June 21st, and it is for 1 day. It's exactly 1 day.
But in April we can see this effect in the sky. Yes.
You can see it on any day that's not June 21st. You can see it on any day that's not June 21st. I can show you more. Here's another video of the polar day. I don't actually know what day this is, but maybe they'll tell us somewhere in the video. But yeah, they don't tell us in the video. But here's another. The sun starts off high.
We know something called the twilight.
And then it never set. Why did the sun never set? It just gets lower and higher. This is in the Arctic. And then the same thing happens in Antarctica. It goes up and it goes down, but it never sets. Okay. So it's the exact same thing happening, and that only makes sense on a globe.
No, Antarctica, we have twilight, bro. We also experience twilight. We experience.
The video I showed you
does. Sky.
The video I showed you didn't have twilight.
You guys don't talk about it.
The video I showed you didn't have twilight.
Bro, we do have twilight. Antarctica has twilight,
in the fall.
Bro. It's
in the
a
fall.
Dark continent. Do you know what dark continent is?
Look. In the fall.
Dark continent,
dude,
sir.
Stop talking. In the fall, there is twilight in Antarctica. In the summer, like this video, there is no twilight. It's just day the whole time.
No, that is a twilight, bro.
This isn't.
But
this is twilight.
There is something wrong with those videos, I think.
This is twilight. Did you just say this is twilight?
There is something wrong.
What's wrong with this video?
Is Antarctica at all.
It is Antarctica.
There is no twilight. I don't see twilight here.
You're right. This isn't Antarctica. This is the Antarctic. This is Antarctic summer. This is the Antarctic summer.
Okay,
we have
bro,
GPS data showing so.
Can we? Okay, can I say? Okay, last time I asked you only a question without any evidence, without any video, nothing. I told you which continent doesn't have a sunset. Period. Can you
Every
answer this
sunset-
question again in front
ev-
of these people?
Every continent has sunsets sometimes.
No, bro. The question is which continent doesn't have sunset? The AI, Google, all intelligent device know the answer. Can you say the answer, please?
There is no
Instead
continent.
by,
There is
showing
no
videos in-
continent. There is no continent that never has a sunset.
Okay, I say again, and people can search this. Which continent doesn't have a sunset? I say continent. I didn't say a country.
I said continent
period.
as well.
Can
There
you
is
answer?
there is no continent where there is no sunset ever.
Okay,
just
guys,
never happens.
all intelligent device. They say all intelligent device. Listen, guys.
Do you understand?
They say
Are you having a hard
that
time?
Norway. Yeah, but bro, it's confusing.
In Antarctica, there are sunsets. You know
can
this, right?
find it.
There are sunsets in Antarctica. You know that, yeah?
Thank you.
In the fall, like on the
Okay.
equinoxes, there are sunsets. There are sunsets and sunrises.
Okay,
right?
so we have. So does Antarctica does have does have a sunset?
Yes,
That's what I'm saying the whole time, bro.
At the equinox, meaning at the in spring and fall, there are sunrises and sunsets.
Yeah. It's look, my friend. We're talking about Norway. Okay, now
In
Norway
Norway,
the
there are
most,
also
continent-
sunrises.
yeah.
So I've literally been to the northernmost city in Norway, on the mainland, during the fall, and there were sunrises and sunsets every day. I've literally been to
Okay, that's
Tromsø.
that's
I've
but
literally
it's
been
not
there.
in Yuli. You know what I'm saying? It's not.
It was in August,
It's
which
not
is
in the day.
sorry, it was in
Okay,
September.
I remember something.
It was in
Wait.
September, and there were sunrises and sunsets every day.
I remember something. Do you know what happened actually?
Tell me.
Okay, that's very nice, very good. I will move this. Because I asked I said before that continent doesn't have a sunset. People can research if they are interested. So now
There is no
I
continent
have,
where there's no sunset.
Maybe this is last question to you.
Okay.
Okay, tamam. It's okay. Very nice, very nice. Now, I have a good question which no one knows about, and no one talks about it at all.
Okay, sure.
Which is a sun apex. Do you know what sun apex is, or solar apex?
Are you talking about when the sun is highest in the sky?
No. So can you search what solar apex first?
Yes, I'm pretty sure solar
Bro, I'm
apex.
not a scientist, but I find this question too.
Solar apex is
turns my
refers to the
head.
direction that the sun travels with respect to the local standard of rest. This is not to be confused with the sun's apparent motion through all constellations of the zodiac, which is an illusion caused by Earth's orbit. Okay, sure. What about it?
So
What about
that
it?
says that the sun have a standing point. The sun have a stand point. So
No,
the
that's not what
question
it's
is
saying.
also talking about the sun. It doesn't talk about the rotation of the Earth.
It literally talks about the direction that the sun is traveling in, which means that it's not at rest, right? That's what it means to be
Okay.
traveling.
Oh,
So
no, it
yes,
is at rest. Yes.
no, it's not. It literally says it
I'm
refers
not
to
a
the
scientist,
direction.
but-
I know, I can tell. It literally says it refers to the direction that the sun travels with, which means that it must be moving.
Okay.
If it's traveling, it's moving. That's what traveling means.
Okay.
I don't know if you know that.
Okay. And now you know which place which the sun have the standing point.
The
Or
sun,
solar apex?
the sun isn't at rest.
Okay, how can it's not a rest, bro? We have Tropic of Cancer, we have Tropic of Capricorn. So one of those, it should have a rest. Come on, bro. Blitz, be a scientist now with me.
No,
I'm
the
not a
sun
scientist.
the sun is
I'm
always
not, I'm
moving.
just whatever. Okay.
The sun is always moving.
Oh, bro, but we have the. Okay, and Tropic of Cancer is the end of the rotation of the Earth, for example, for the tilt. You know the tilts of the Earth.
Yes,
has-
the
it
Earth
has
is
an
tilted
ending
because
point.
the Earth is a globe.
So you have to tell me now. Yeah. So okay, now the tilting of the Earth have an ending point, and then to
the tilt
again
doesn't
back,
have.
okay?
What? No.
So now you can
Wait,
tell us.
hold on. The tilt of the Earth doesn't change. You know that, right?
No, it doesn't change. I know.
Okay, so then why are you saying it has an ending
But
point?
it has about
What are you
60
talking about?
degree.
It's
60
20
degree
it's,
like this.
it's
and
23 and a
60
half.
degree
It's 23 and a half degrees.
there. Okay, so in 23 half degree, it should be an end point, and that's what we're talking about.
What do you mean
solar
an
apex?
An end point of what? The solar apex has to do with the motion of the sun, not the apparent location of the sun above us. It doesn't have anything to do with that.
Bro. Okay, do you know what Greenwich Meridian is?
Yeah, I've been there.
Right now. Go ahead.
I've been to the Greenwich
Are you
Meridian
been
line.
there?
Yeah.
Now you're trying to to show you everything what the solar apex mean. I have to go. Come on, bro. Please show me that you are a real scientist, man. Please.
I already told you what the
Come
solar
on,
apex is. I looked it up for you.
Okay, so the all question. Okay, the all solar apex it's have to do with the Greenwich Meridian. Okay, so this Greenwich Meridian, it's a rest.
No, it doesn't. It doesn't have anything to do with that. It has nothing to do with the Greenwich Meridian or anything.
So why we have a longitude? Why we have a longitude which is 0 or 12?
It's just a convention.
You know what I'm saying? 12 or 0.
It's just a convention. Yeah.
Yeah,
it's just
but
a convention. The solar apex
But
is just the direction that the sun is moving. Solar apex is just the direction that the sun is moving through space.
Yeah, through space, but through also the tropics of the Earth. You know, the geographic.
No, it has
of the Earth,
it has nothing to do with the tropics.
For
it has
example,
nothing to do with the tropics.
If the sun is on a Greenwich Meridian,
it has nothing to do with the tropics.
Sir, if the sun, okay, if the sun it's at the Greenwich Meridian, you mean you are in London? See what I mean?
Yes, I've been to London.
It's in London. It's above London. That's what I'm talking about.
That's where the sun appears to be. That has nothing to do with the solar apex.
Bro,
Are you struggling? Is this hard for you?
Man, bro, no. you make it difficult for us and for the people.
I'm aware. I make it difficult for flat earthers to make sense because they don't make sense. I'm aware. The sun the sun never appears above London. London is too high in latitude. But yes, when you're at say solar noon, the sun will be the highest in the sky, and that will occur at exactly noon when you're over Greenwich. What's your point? That has nothing to do with the solar apex.
My point is that the Earth is a clock, or the sky is a clock. You know what I'm saying?
Okay,
and
you
it
can.
shows up all
So
the
why
stars
did you bring up the solar apex?
Fixing at.
Why did you bring up the solar apex then?
The solar apex. The solar apex. I show you what is the Greenwich Meridian and London, because
the solar apex has nothing to do with those things.
Like you said. Yes, bro. How not? How not?
The solar apex is literally the direction.
To do with too?
The solar apex is literally the direction that the sun is traveling in through space. Right now, the solar apex is in the constellation of Hercules near the star of Vega. That's it.
I know it
has nothing to do with the meridian.
It's trying. The solar apex, it shows you the longitude things on Earth. That's the longitude.
No, it doesn't.
Altitude.
Solar apex has
altitude is that's daily things.
It has nothing to do with that.
Okay, do you know what happened in the same day? Okay, the day of the solar apex. Do you know what that means?
The solar apex isn't a day.
The people on Earth.
The solar apex isn't a day. It's a direction.
Bro, that's a day of your July, man. That's the day of July.
Are you trying to talk about this? Are you trying to talk about the solstice?
Solstice? No, I forget what that is in English.
The solstice occurs on June 21st, and that's when the sun is over the Tropic of Cancer. That's the summer solstice.
Exactly, that's what I'm saying.
That has nothing to do with the solar apex. You should read more.
No, but solar apex is a Greenwich Meridian thing, my friend.
No, it's not.
You know what I'm saying?
Completely unrelated.
I didn't know that. That's a new things that I found on internet. You know what I'm saying?
So why'd you bring it up?
Science.
If you just learned it, why'd you bring it up?
Because that shows up that the sun It's just rotating above the Earth, and now it shows up what is
The solar
sun on
apex has nothing to do with the motion
longitude.
of the solar apex has nothing to do with the apparent motion of the sun above the Earth. Like, it has nothing to do with that. They're unrelated phenomena.
Okay, so what does that prove then? What
I don't know.
solar
You brought it
eclipse
up.
for you then?
You brought it up. I don't know why you brought it
I
up,
just
because it
said-
seems unrelated.
I just said I want to see what your perspective. Well, yeah.
You just brought up the
just
solar
said, I
apex
just
as like
explained.
a complete non sequitur.
Yeah, but solar, you can search this up. You can search this up, man. It
I
shows
already
up
did.
that solar apex means a rest place of the sun. And
No,
we
it's
thought- and
not.
we said-
It's
I said-
literally not. Here, let me
So,
show
yeah.
you. Here you go.
Okay.
Solar apex. I don't know if you can read this, but hopefully you can. The solar apex, or the apex of the sun's way, refers to the direction that the sun travels with respect to the local standard of rest. This is not to be confused with the sun's apparent motion through all constellations of the zodiac. That's what well, actually, you're confusing it with the axial tilt. But again, these things are unrelated. Solar apex has nothing to do with the sun standing still or something. Completely unrelated.
So, bro, you saying it, bro? Please don't say that. Please don't say it at all. Don't talk about rest, bro. The information says that the apex is talking about the rest of the sun. You say
It seems like you're struggling. Can he?
There is only a rest of the Earth.
420. Thank you for the eight Canadian dollars, which is like $6 normal. Can you tell me what the Greenwich Meridian is, please? Top sport. What do you think it is?
Greenwich Meridian is something which is, we call it, how I can say that? It's a zero, it's an hour, it's a 0 clock, or 12 hour, we say.
Is it?
It's in the middle of the Earth.
It's in the middle of the Earth.
That's the middle of the Earth. Yes, that's the golden ratio. You know what the golden
So
ratio
wait a minute.
is?
So is the Earth a sphere then? Oh wait, so this has to do with the golden
The Earth
ratio. I
is a
see.
geocentric.
By the Earth is geocentric. You know that geocentric Earth is a sphere, right?
Sphere? Please, not sphere, bro. You mean Greek made it sphere and they call it geocentric? Is that what you mean?
Yes, that's the original geocentric theory. Is a spherical Earth with the stars around it. That's the original
I respect
geocentric
Greek
theory.
people. I have nothing against Greek people. They did the best things that they can do, but we are more technological, so we can.
Yes, you're right.
observe
Now
more
we
things.
know. Now we know that the Earth is a
Period.
sphere, and the Earth is moving, and the stars are staying in the same place. You're right.
No, bro,
we have
I said the
surpassed
Greeks,
them.
they did all best, and they find out that the Earth is a sphere. So how you come up,
Yes, now the Earth is still a sphere.
And you say the same thing?
The Earth is still a sphere.
Bro, you
Yeah,
say
it's
the
just
same thing
it's
as
the
Greeks.
Earth is. Well, no, it's slightly different. Now we know that the Earth is moving and that the stars are staying in place. Roughly. It's still a sphere, though. They were right about that.
Oh, bro, there is many things that which proves that not. For
Okay.
example, you know what about the pyramids? You guys don't know nothing about who built the pyramids, why they
Yeah, we
built
do.
the pyramids. And
Yeah, we absolutely do.
how
Do you
they
want
built the pyramids.
you want to know something that's extra funny? We actually know exactly who built the pyramids. We know the name of a guy who built the pyramids.
Wow.
So maybe you should read more.
Confusing now.
Yeah, it should be, because this is like known. This has been known since the 21st, since 2013. We have the name of a guy whose name was Merer, Merer. We found his diary, and he was a mid-ranking official with the title inspector. And in particular, he was an inspector during the time when the Great Pyramid was being built, Pharaoh Khufu's pyramid. And in particular, it actually describes, let me see if I can find it. Is it Papyrus B? Yeah, it's Papyrus B. It actually describes several months of work with the transportation of lime from one of the quarries, let me make this smaller, from one of the quarries to another. Let me make it a little bit smaller. It describes transportation from one quarry to another, where they're literally bringing stones from a place where they dug them out of the earth, and then brought them to the pyramids. So we know exactly how they built them. We know who built them. Literally, this guy built the pyramids. I mean, he had a lot of help, but like it was this guy and then a whole bunch of other guys. Like we know this stuff. This has been known for over 10 years.
But the theory says that they moved the 1 ton stone stones, and that's impossible, bro.
Why is that
That's
impossible?
impossible, bro, to build something like that. We have
Why is that
another
impossible?
theory which is more fact and
I
more
mean, like,
makes
this
more
is
sense than
delusional.
yours.
This is delusional. Why do you think it's impossible?
Yeah, bro, how you can move something like that if you don't
Here,
have
let me show you another.
people in the game around you there?
So this is called the Thunderstone. This is a painting of something that happened in, what was it, the 1770s, I want to say. So this is a stone that weighed 730 tons, I think. 1,250 tons. And they moved it with no machines, just people and wood. And pulleys and stuff. And actually, that stone exists. It's this stone.
It as a punishment.
It's that stone.
I don't see this is okay. I don't see this is intelligent from them, but this is just a punishment from the king or something like that.
It wasn't a punishment.
Bro,
they needed.
Look at the picture, bro. Please.
Shut up, dude. Shut up, dude. They needed the stone to build the statue. So they literally dug the stone up and then transported it like a very far distance, I think. In fact, it took 400 men 9 months to move the stone. They made about 150 meters of progress a day, while on level ground, and if it wasn't on level ground, then they were slower. But like, this is a thing that happened. They found its I guess it was found 6 kilometers inland from the Gulf of Finland. Like, this is a thing that happened back in the 1700s. And they moved it without any machines. They just used pulleys and wood and lots of manpower. And this was like 1,000 times heavier than the stones used in the pyramids.
Yes. Okay, but we have the giant people at that time.
In the 1700s, we had giant people?
In 1700s? Who said in the 1700s they built the pyramids?
That's how they moved that. The Thunderstone was moved in the 1700s. And we know how they moved it because there's literally paintings.
Yes, it could be, bro. It could be. You can move it.
Okay, so then why do we need giants? Why do we need giants to explain the pyramids? Why are giants involved at all?
Bro, it's something huge.
No, the Thunderstone was 1,000 times bigger than any of the stones in the pyramids.
But it doesn't matter.
Do you just believe everything that you see on TikTok? Do you just believe everything that you see on TikTok?
Moving. Okay, moving is not
wait,
like
answer my question.
You're gonna build.
Answer my question. Do you just believe everything that you see on TikTok?
No, I'm a religion, bro. I'm religious. I'm Muslim.
You know that
we have Asian text.
You know that so we literally have records.
We controlled this place.
I'm sure.
Bro,
you know
controlled the Middle East for a long time.
Whatever. We literally have records of one of the guys who helped build the pyramids. He explicitly tells us how they moved the stones. So I don't know why you're believing this random conspiracy theory that it was giants. It wasn't giants. It was it was a crew of like 30 or of like 40 dudes who were moving blocks that are 2 to 3 tons each, and they moved around 200 blocks a month.
Okay. You can see how the stones and how the thing are built with each other. Mixed with each other. It's like intelligent. It's not something you can. You know what I mean? It's not.
Yes, they were assembled.
They cut it.
They were cut to size at the quarry, and then they were brought to the pyramids by engineers.
Okay, what
are you talking about?
Okay, I don't think so.
Okay, bro, I mean, look, the evidence is right in front of your face. So if you don't think so, then you're just shoving your head in the sand, I guess.
Have you seen how they built this black granite? It's a black granite.
Yes, it was very heavy, and we've moved heavier things with manpower before.
So you know how we build granites right now, yeah?
Are you talking how you cut it?
We don't cut. We build it. It's a melt. This
you don't
limestone and black granite. red granite, we melt it. It's melting. It's like a product,
Wait.
a powder, you know.
There is natural granite, right? You know that there's natural granite, right? That you can just pull from the earth.
Yeah.
Okay, so that's what they used in the pyramids. They didn't make granite.
Yeah, but they didn't cut it. They melt it. That's what I'm saying. They melt it.
Okay,
and
is there
then
any
they build the
evidence of
pyramids.
this?
Easy.
Is there any evidence of this?
Yes, that's
Where's the evidence?
Bro, that makes more sense.
It makes more sense that they melted granite rather than just cutting it from. Look, we know the quarries. We know where the granite was mined. Like the quarries are known.
Bro, you can observe that they didn't cut nothing.
Literally, we know where the granite came from. It came from the ground. It came from the Aswan area. Like
Yes,
we know where it came from. Are you just making stuff up at this point, or is this a meme? Are you trolling me?
It's more. I know, bro. I know because it's a more solid thing that I can use in my building. So it doesn't mean I'm gonna cut it.
They can mine it from the ground. That's what they did. That's what they did. Yeah, they literally cut it and moved it.
Okay.
Yeah.
Boki, they melt many things and then they build things easy.
Okay, buddy. They melt the
the
lasers carried around blowtorches and melted the granite. Yep, you're right. You got it. You got me. I'm converted.
Bro, you can only use the sunlight, bro. You can only use the sunlight, and you can melt some stones which are actually iron. You know, we have iron stones too, and they use also this type of stones which are actually iron. You know what I mean?
Okay, sure. Melt. I'm sure.
So yeah, you cannot observe the pyramids, and you're talking sometimes about God, you're talking about something about flat Earth, and you have pyramids in front of your eyes. You cannot tell us who built it and how.
I literally gave you the name. I literally gave you the name of a guy who built the pyramids. I literally told you his name. You're gonna
say Elon Musk.
No, his name was Mirror. His name was Mirror.
Okay.
Like we literally know his name.
We hope Elon Musk builds something like it.
We literally know his name. All right, I'm gonna let you go unless you have anything useful to say.
Thank you.
Anything else?
I appreciate it. No, next time, inshallah. Thank you for that. I appreciate my friends. Cheers.
Hopefully he'll come to his senses, inshallah. All right, there was a Neo Yahtzee who was in the guest box, or who was in the chat. Maybe he's still in the guest box. That'd be a delight. We love talking with the clinically delusional. Unfortunately, he is not here. What was the guy's name? Some dude in Canada. Some dude in Canada. You want to come up and talk about? Is he still here? Is the Neo Yahtzee still here? Enchilada to you too. No, that's impolite. All right, some dude in Canada. We're looking for you. We're gonna send you an invite. You're gonna come up and you're gonna defend your silly Earth shape. Oh, I don't think he's here anymore. Bummer. All right. Let's bring up Lung Liquor. Welcome. That's weird. All right, let's bring up Carter Pewterschmidt. Carter, how's it going?
I'm good. How are you doing, brother?
I'm doing all right. What shape do you think the Earth is?
I think it's an egg shape, and the guy before, he was wrong. In Islam, it is said in Quran, it says that the Earth is in the shape of an egg.
Okay, you think the Earth is egg-shaped? So do you think that that's like basically round or like spherical, or?
Yeah, you can say that. You can say that. I just wanted to join just to disprove the guy saying that in Islam the Earth is flat. No, it's not.
Okay. Well, thanks for being here, but it is opposition only. All right, we have a guy named Ethanol in the guest box. Let's bring up Ethanol. Ethanol, how's it going?
I'm so sorry. I accidentally clicked on it. I'm gaming at the moment. I'm just listening. Sorry.
You're good.
But
You're good.
Very good.
Thank you. Have a good one. All right. We have somebody named Alan in the YouTube thing. Let me see if I can get him in. Alan, can you hear me all right? Let me unmute you. I can hear you. Can you hear me? Alan, can you hear me all right? Alan? Testing 1, 2, 3. I can hear you.
Yes,
can you
sir.
hear me? Wait a minute. Okay, they can hear you. At least TikTok can. Let's double check if YouTube can. All right, so what shape do you think the Earth is?
I can't hear you on the
1 sec.
thing that I'm on. I can hear you on YouTube, but not in the browser that I'm connected
Oh, that's
to you on.
strange. You still can't hear me? I can hear you.
Flat.
Oh, there's a huge delay. Okay, 1 sec. Audio source. Can you hear me now? Is that better?
Testing 1, 2.
I can hear you. Can you hear me?
Perfect.
Great.
Perfect.
Okay.
There
I just
we
want to
go.
double check and make sure that we're not getting double audio. TikTok, are you getting double audio from me? No? Okay, and I think we're probably okay on YouTube. People are saying your audio is low and staticky.
Okay,
I think it's okay though. It sounds fine on my end.
No, I heard it coming through the YouTube. It did sound not correct. Give me 1 second. Let me see if I can fix this.
Okay.
I don't want it to sound horrible.
Sure.
Let me close OBS. I'll be right back. Give me 1 sec.
Yeah, so it sounds fine on TikTok. Seems like it's a YouTube issue.
All right, I'm back. Can you hear me?
I can hear you just fine.
All right,
Yeah, let's just double check and make sure that TikTok
Okay,
or YouTube can hear you.
Yep. As long as the YouTube
I'm
either good.
really delayed in the thing.
I can't see you on here. Is it possible to see you?
I can't. I don't think I can use my screen, my camera twice.
No worries, no worries. I'll put you up on YouTube so I can see you on the other side.
Okay, but there's gonna be like a 8-second delay or something. So
Yeah.
unless I'm holding like a freak out response, right? Anyway, so I think we're no, it still sounds bad on YouTube. Let me double check. Oh yeah, no, it is really bad on YouTube. It actually might be on my end. Let me. Video packet loss indicator of video green is good. Okay, let me just double check your audio settings. What if I'm gonna turn off your video really quick, just to see if it's a video, like if it's that kind of issue.
Yep, gotcha.
It didn't turn it off for some reason.
They're saying the sound is better now. It's like a mixed bag of results.
Okay, well, now it's good, so let's just go with that.
Awesome.
Your video's not up. Right, so
Cool.
You think the Earth is flat?
Yes, you said you asked earlier what I think the shape of the Earth is, and I wanted to present to you a null hypothesis for flat Earth, for flat versus globe.
Okay, what's the null hypothesis that you're using here?
Okay, cool. Is it? I'm sharing my OBS cam now. Can you can see this?
It's very, very tiny.
I got you. Can I manually screen share on here? Is that possible? Yes, it is.
No, I don't think so.
Show entire screen. I think we're about to make it happen. Inshallah.
Yeah, I can't see that.
No, didn't work.
It's
yeah,
tiny.
Didn't work. Rest in pieces. Okay, no worries. I'll just run you through it with the auditory version.
Sure.
So using the sky to prove the shape of the ground, you can't use the sky to tell you what the shape of the ground is, but you can use it to tell what the shape isn't. So using the null hypothesis format, which I'm sure you're familiar with, we're going to make our H1. Earth is planar and measurements of curvature are dependent on the positions of celestial bodies. And H1, I'm sorry, yeah, H1.
Sorry, repeat
H
that.
naught was H naught is the Earth is planar and measurements of curvature are dependent on the positions of celestial bodies.
Okay, that's fine.
Okay, my alternative hypothesis is the Earth is globular and measurements of curvature are independent of celestial bodies. Make sense so far?
Well, sure, but that's not the globe Earth claim, right?
No, it specifically is. Do you know what the graticule is? The latitude-longitude system?
I don't know what the word graticule. I don't know what graticule means. I've never heard that word before. By the way, your like we can see your thing, but it's very, very tiny, and I can't make it bigger.
Yeah, no, that's no worries. I'm just gonna walk you through the explanation.
So I'm actually gonna disconnect that because otherwise we can't see your lovely face. Or can you?
Oh, you know what? Yeah, you know what? I'll go back on face. No worries.
Yeah. It's just better that way.
Yep. Awesome. Okay, so let's see, where were we at? So the graticule, right? That is a spherical coordinate system that is represented by latitude and longitude. And it has a primary definitive characteristic called a fundamental plane that intersects through the center of it. You might, call it the equator. Okay.
Sure.
So do you know how that coordinate system was constructed? And,
no, I don't. I don't know the history of the latitude and longitude system. No.
Got you. Well, it's really interesting.
Is it relevant to the conversation?
No, absolutely, because this is the baseline fundamental for all maps. And
well, no. I mean, but the history is irrelevant. You can test whether it's a particular shape without knowing the history, right?
What's your test?
Well, I mean, it presumably you were going to present one, so it shouldn't depend on the history.
Well, if you don't know the history, you're not going to understand what my point is, what the point of this null hypothesis is.
Look,
I understand
you don't need to know history in order to test a hypothesis.
If you don't know how the map you're using was derived, you can't know of its correctness, right?
No, that's not true at all. You can test whether something is correct or not without knowing where it came from.
Okay, how do you test measurements of curvature independent of celestial bodies?
I mean, you could literally do geodetic surveying, right? You could literally measure distances.
Exactly. Do you know what geodetic surveying is?
No, I mean, you could literally measure curves or straight lines or whatever. You can measure distances on the surface of the Earth. You don't need to look at the sky to do that, right?
All right. If you would, please, because this is very important, because this is why I was going through the history, because geodetic surveying is super relevant to this coordinate system and how it was used to, measure the Earth, right?
Sure.
So what they started off with was the nautical almanac, where they had the GP positions for all of the stars, right? And they determined all of these by taking cosines to the stars and using the coordinate system itself, one of the latitude lines extending from the North Pole to the equator, which comes out to a distance of 6210. So they use that as their baseline, and then they use all units of measurement, so meters, kilometers, miles, nautical miles, all of that are fractions of the terrestrial meridian. So what they can do with that, now that they have a coordinate system and they can follow cosines to the stars if they use a capped elevation angle. So when you do that, you can use the ratio of the angle to get the distance. So when they started traversing the land to take zenith measurements of the stars, so what they would do is they would look out, they would see a star at like their 45-degree angle, ratio that out, get the distance, traverse the land, go underneath the star, look up. And when they started taking zenith measurements, the star was never quite in the center of the telescope like it should be if you were completing a 90-degree triangle, right? Make sense so far?
I just don't see how it's relevant.
Well, my hypothesis, right, if we call back to that, is that the Earth is planar and measurements of curvature are dependent on the position of celestial bodies, stars, planets, moon, sun. And the alternative is that the Earth is globular and the measurements are independent of the celestial bodies. So
which one's your null hypothesis?
My null is that the Earth is planar and the measurements are dependent on the position.
Why is that the null hypothesis rather than the alternative hypothesis?
You think I should flip those around?
Probably.
So my understanding of the null hypothesis was you put the thing you think to be true and then you go over evidence to falsify it, and if you fail to falsify it, you keep the null hypothesis.
No, the null hypothesis is the thing that is when you're trying to prove that something is true, you make that is your alternative hypothesis. The null hypothesis is just the opposite.
Okay, so vice versa, switch it then so that it's easier to digest. Now, now that you understand the premise, though, right?
But given your own premise, where the null hypothesis is that the Earth is globular and the alternative hypothesis is that the Earth is planar, in that case, your own statement that you cannot prove a hypothesis, you cannot say prove the shape of the Earth by looking at the sky, but you can disprove the alternative hypothesis. So even with your own description, you're not going to be able to prove the shape of the Earth, that it's planar, by looking at the sky.
You can tell what shape it isn't, though, right? That's the primary feature of this. Yes, that's why we were going over the history of geodetic surveying. That's why it's important to understand what geodetic surveying is. It is not.
I don't think that you need the history in order to actually explain what's going on. It just seems irrelevant.
I would be much appreciative if you would let me get through my point instead of cutting me off midway through before you can hear it.
I mean,
it's not very productive.
You rambled for a few minutes about the history, which wasn't relevant for the actual experiment you're about to describe.
Nope, we're talking geodetic surveying right now, my man. You just don't know it because you don't know the history because you won't let me finish.
Well, I don't care about the history. I care about any experiments or any observations that you can make now.
Yes, and we're going over how to interpret the measurements that we make now with geodetic surveying and how they're done. And if you don't know how they're done,
do you agree that you can travel a distance? You can just travel a distance in a car, right?
Mm-hmm.
So you don't need to use the stars to do that, right?
Did you understand what I said when all units of measurement are ratios of the terrestrial meridian, which is in reference to the sky, the position of the stars?
A mile is not.
Yes.
A mile was based off of some Roman thing, I think.
All units of measurement are derived from as a fraction of the terrestrial meridian. Do you understand?
That's not true. A second is related to a cesium atom.
You can use a coefficient to link the speed of light to the same thing as well.
No, that's how the second is defined. It's not in reference to the speed of light.
Oh, I'm sorry. The oscillation rate. Sorry, I was talking. Yeah. They also use a coefficient for the actual speed of light to link it to the same thing to make it a meter as well.
Yes, you can make a meter and you can define a meter off the speed of light and the second. That's true.
Right. Okay.
So no, the measurement doesn't have anything to do with the celestial sphere. The distance of a meter in particular.
Certainly does, because they use a coefficient to link it to the fraction of the graticule.
Does the speed of light have anything to do with the celestial sphere? Measuring the speed of light?
No, but when you use
does the cesium atom have anything to do with this with the celestial sphere?
No, but do you understand that?
So then the meter has nothing to do with the celestial sphere.
Incorrect.
Well, look, the meter is defined as the speed of light, as it's defined as a particular fraction of the speed of light times 1 second, right? That's how the meter is defined. It's 1/299 millionth, whatever, of the speed of light times a second. Now the speed of light is defined. You can just measure it. It's actually kind of just defined to be 299 million whatever meters per second. A second is measured empirically using cesium atoms. So the meter has nothing to do with the stars. It's just a thing that's defined in terms of the speed of light and a second.
All right, here we go. All units of measurement, and you can look this up later on your own time, but I put a link in the YouTube chat if you're able to put that up for me. All units of measurement are linked to the terrestrial meridian, which is linked to the stars.
I don't see it in the YouTube chat, by the way.
Okay. In addition to that, they use a coefficient to make the speed of light a ratio of that as well.
So, although it's not directly linked, and you could use the oscillation rate of cesium to define a second, I absolutely agree with that. An oscillation rate of 9,192,000,000 some oscillations a second, right? I'm on board. Sure. I'm with you, right? But also, that has been incorporated into the graticule. That is why I am.
Sure, but you got the causation in the wrong direction.
Well, if we agree that they are all ratios of the terrestrial meridian, then we can proceed.
We do not.
Do you have an email that I can contact you at? Because I would like to send you the actual documentation of all this so that we could go over this again.
I think it's in my... I don't want to say it out loud, but I think that... it's drblitzphd@gmail.com. Blitzphd@gmail.com was taken for some reason. Don't understand that, but...
Dr. Blitz.
Sure.
At to follow up on you or follow up with you on this, because I notice a lot of people you talk to
don't really know the significance of the history of all of this and how it ties together. And obviously, if you look at it through the lens of like, oh, we have geodetic surveying, it's like, okay, cool. I agree. You can take measurements, you can cosine things out, you can reference the stars to make the measurements. But what you aren't familiar with on the aspect of geodetic surveying is that it's all in reference to celestial coordinate system transformations to with respect to where the ideal position of a star is based off of parallel light rays incoming. Yes.
Do you think that, let's say that the Earth didn't have water on it just because it makes traveling easier, right?
Hang on one second. I would like to answer a YouTube question in the chat. So my boy Fenton Molly says, why can't he just move forward? I could move forward, but it would not be...
If two people in the conversation don't have like a mutual understanding of things, then proceeding forward isn't going to make a difference. It's not going to be
gratifying for either of us to talk past each other. You know what I'm saying? So if we can't reach a fundamental understanding on the ratios of measurements, then we should focus on that and clear that up first, and then proceed forward, because I think this could be a really good conversation, but it will require some effort on your part,
as there's information that you probably never heard of.
So let's say that the Earth has no water on it just because it makes it easier to travel, right? Imagine there's no water, it's completely barren.
Sure.
And imagine that you were blind. So in principle, you could travel in a straight line, just get in a car or just walk. Maybe you have it's hard to walk in a straight line when you're blind, I imagine. Maybe I don't. But anyway, in principle, you could, without having anything to do with the stars, you could just walk in a straight line for 10,000 kilometers. And then you could turn left, walk in a straight line for another 10,000 kilometers, and then turn left again and walk in a straight line for 10,000 kilometers. Now, regardless of what's going on above you, regardless of what the sky is doing, what the sun is doing, what the stars are doing, you will either end up back in the same place again, or you will not. Do you agree? Okay.
Yes.
Now, if you end up back in the same place, the Earth is a sphere. That's a property of that's a property of the intrinsic geometry of spheres, right? That in particular you can draw a triangle that has three, right? And if you don't end up back where you started, then the Earth is a plane. Well, if you end up 10,000 kilometers away, then the Earth would be a plane, right? If it was some other distance, then it might just be a larger sphere. So this is a thing that, I mean, at least in principle, could be done without any reference to the sky, right? Why not?
It could, but here's the thing. You would walk that, you would never
know if you're off or not, and no one's ever done that. An equilateral triangle of 1 kilometer has an angular excess in it of 0.002 arc seconds. It's imperceptible, right? You can only get angular excess.
Very, very small. What I'm saying is that it's not necessary. Go ahead.
Bro. What you would only get spherical excess over these large distances like that, right? Now, nobody has ever done the walk in a straight line and make the triangle like you're suggesting. All measurements that have been done like this are done over smaller distances, and then zenith measurements of stars are referenced, and then corrections are done, right? They call them astronomical corrections, and they do astronomical transformations to line up the zenith measurements. And then you get into two different types of corrections to facilitate why they're off or not. One would be the deflection of the vertical due to the Earth being an ellipsoid. The other one would be due to gravitational anomalies due to the Earth being a geoid. The geoidal model is a gravitational
model that intersects with the ellipsoid model to create offsets where they can say that, it might be a little flatter, rounder here because of the zenith position being off, but maybe it's still off a little more. So they say that we need to introduce a gravitational potential correction.
Sure, there are lots of corrections. I agree. But the point is that it's at least in principle possible to measure the shape of the Earth, to do this kind of thing, and without referencing the sky at all. Right?
That was my hypothesis, and it is not possible to substantiate curvature because the curvature could be optical. You actually have to reference flat or curved in reference to an external source, and that would be the stars, my man.
Wait a minute. So I'm pretty sure you just agreed that actually, at least in principle, it is possible to do this experiment. I mean, it's obviously not practical, but it's at least in principle possible, and that has nothing to do with the stars.
Sure, but no one's ever done it, and
Okay,
no one's
so your
ever,
principle was false.
no one's ever verified the angular excess. Well, you're
So-
you're prefacing a complete hypothetical.
Well, my point is that it doesn't require looking at the sky. You can learn things about the geometry intrinsically without any sort of extrinsic reference. Now, one of the ways that you can do this is you can, for example, just drive long distances, like thousands of kilometers. That's a thing that you can in principle do. If you drive through a rectangle, long distances, then like thousands of kilometers, you can at least get a decent approximation. You can, and like this is the kind of thing that's been done, right?
I completely agree that when you use a unit of measurement derived from a terrestrial meridian, it will actually correspond to a place on the Earth. That's why that part of the conversation is fundamental, bro.
To be clear,
because
meters
your argument is my argument.
Meters derived from the terrestrial meridian? No, meters are the second times the speed of light. That's what a meter is.
Yes,
one 299 millionth of the speed of light times a second.
Do you remember that coefficient that we were talking about that you're unaware of? And
I'm only talking about meters.
Please don't interrupt. The fundamental impasse that we're at right now is that all units of measurement are linked to the terrestrial meridian, including the speed of light. And
tell me how that works.
Through a coefficient that's used.
What coefficient?
I will send you the details for it.
Yeah, what coefficient? How do you measure the? Why is it required to use some sort of celestial features to measure the speed of light?
Buddy, I didn't make the coefficient. It's not.
No, I'm just asking you.
It's just
where
what
does that
was
come
done.
up? Where does that?
What's that?
Are you talking about originally, when the speed of light was originally measured, like 300 years ago?
No, this is a modern thing.
So you can measure the speed of light using pretty rudimentary tools,
without
referencing the sky at all.
I'm not contesting the speed of light, right? I'm saying there's a coefficient. Listen carefully, please.
What coefficient? Coefficient relating what?
I'm going to send it to you.
Okay. Or you could just tell me what this is a coefficient of, because coefficient is just a word. It's a term in front of some variable.
Yes, they introduced a constant to make it a ratio of the terrestrial meridian. That's
okay. What constant? What ratios?
Sending it to you now.
Or you could just tell me what the ratios, what it's a ratio of, what the constant is.
It's a ratio of the terrestrial meridian.
A ratio is a relationship between two things. You only listed one thing.
They're linking the speed of light to the terrestrial meridian.
Okay. So the terrestrial meridian is a noun. It's not a number.
6210 is the distance that they're using. That is the length of a terrestrial
6210
meridian. Man, you're going to interrupt me before I can say it's the length of a latitude line from the North Pole to the equator. Please don't do that anymore.
In what units?
Miles. You could use miles, you could use kilometers, you could use nautical miles. These are all the same units of measurement.
Now, what does that have to do with the speed of light?
Hey, man, I'm going to send you the email for everything, and we'll recontinue this, because I feel like you're having a hard time following it without having seen the math for it. And I think once you see it, we can continue the conversation.
All right. I'm awaiting the email.
All right. I appreciate your time. I'm going to head off.
Later, Gator.
Later.
That was exactly as productive as I expected it to be honest. I'm not gonna lie, that was exactly as productive as I expected it to be. All right, let's talk to. Oh, there were a lot of people in the chat who are like really big fans, so you guys should join the guest box too. Dad Bot Official, how's it going?
It's going pretty good. Can I please take a minute of your time?
No, you have to tell me what shape you think the Earth is.
Oh, that's sad, because I've been hearing this guy lying. I'm a land surveyor, okay? And I find it sad that this guy has been telling things about my profession that I love dearly, about measurements, and I find it sad. I just got triggered, and
I'm sorry,
and it's so... Yeah, no, but he's lying about the measurements, like the history about measurements, and most of the people don't even know that a French feet is different than an English feet because it was, I mean, French kingdom, the king, just read it. It's like a French foot is 13 inches, which an English foot is 12 inches. And he says the stars and everything is like, I was just triggered. We could do, we could do an arbitrary system, like give a coordinate of 0, 0 to a drone with LiDAR on it, which is, you know what LiDAR is.
Yeah, I know.
And we could just, we don't need the stars. We could just put a coordinate of 0, 0 on a drone, fly it up, shoot it straight level across, and we could just LiDAR and map the thing and show the curve. It's as easy as that. You're amazing, Dr. Blitz. I'm a fan, so I'll let you go and let you debate with. Thank you so much.
All right, take care. Good luck. All right, let's bring on another guest. I think Alan's somewhat well known. I don't know what his response was to the final experiment. I know that some flat earthers actually became globe earthers, at least one stopped being a flat earther. This is Jeranism, so I don't know what Alan's take on it is on that though. It'd be interesting to hear. Chip Gillo, how's it going? Chif? Oh. By the way, all, if you want to support what I'm doing, if you like what you see here, consider joining the Discord. Consider liking the live or liking the live stream on YouTube, which regardless of what platform you're on. There's also a Cash App in the link to my bio. If you want to support me, you don't have to, but it's a cool thing to do. It makes me want to do this more, especially with TikTok going away. That's going to suck. Notification, how's it going?
Yo, what's this about?
Are you a child? You sound like a child.
Yeah.
Okay, go on, get. All right, let's bring up another guest. Flat Earth Raul is in the chat. Maybe we should bring up Flat Earth Raul. He sounds like he's probably a flat earther, right? If you want to come up, Flat Earth Raul. Invite sent. If I donate, will you throw it back? No, I will not. I have some semblance of self-respect. All right, Raul seems like he's not interested. That's okay. Raul can't defend his position. Saint,
hey,
how's
Blitz.
it going?
I don't believe in flat Earth, but I just had a question. What happened? I remember you used to have like a bot or something that would join and like advertise for you or something. What happened with that?
Currently under development.
Oh, okay, gotcha. So it's something that's going to come back in the future?
Yep. With even more features.
All right, awesome. Well, I just subscribed to you on YouTube, and
well, thank you. Yeah, everybody subscribe on YouTube.
Yep, Dr. Blitz on YouTube. Everybody go drop him a follow.
Do that. All right, take care. Right. Thanks for being here, man.
Yep.
Wasn't the kilometer originally defined in relation to the Earth's radius? Absolutely was. However, is no longer defined that way. Let's talk to Daniel Magneto. Daniel, how's it going?
Pretty good. How are you?
I'm doing all right. What shape do you think the Earth is?
Cube-shaped, obviously.
Are you trolling me, buddy?
Yes. Sorry.
Get out of here. Go on, get. Go on, get. Still waiting for that email from Alan. Still nothing. Rowan Blitz wants to talk about science. Oh, you don't want to talk about science? Oh, is that because science basically shows that, we can't have a flat Earth? We need a time cube guy. Look, I started feeling bad making fun of the time cube guy when I found out he was actually schizophrenic. And so then I feel bad. Chris, how's it going? What shape do you think the Earth is?
Oh, hello, Dr. Blitz. I'm an astrophysicist, so that comes.
So you think that the Earth is truly flat, correct?
No, I'm an astrophysicist. I just want to tell you that I support you. I follow you on TikTok, and you're doing a great job. Actually, I was on live about flat Earth just a few hours ago. And
then you hate yourself, I see.
There was this person who told me, obviously he was trying to convince me that the Earth is flat, and I asked him, if the Earth is flat, how are the aurora lights formed? Because I live in Europe, so
it's magic, don't you know?
Yeah, and he told me there is a magnetic mountain on the North Pole.
That's what they think.
Yeah, and I asked him what is a magnetic pole, the magnetic field made out of, because obviously we know that you have for example, if obviously you know that if you shake electrons at a certain direction, then they release electromagnetic radiation, and you have like. And I started to ask him like those questions that are connected to like quantum physics and something like photon field, electron field. He was like, he started to completely just like explode and shout an answer. They kicked me from the live.
All right, Chris, I gotta let you go though because you are not opposition. But thanks for being here.
Take care.
All right, currently the guest box, I believe. Let me double check. Yeah, we call that crashing out. True. Guest boxes. Oh no, we have Jesus in the guest box. No way. Is that actually the real him? Is he him? Is that him? Jesus, is that you?
Yeah, it's me, mate.
It's
the one. It's the one and only.
The one and only. What shape do you think the Earth is, Jesus?
Oh well, of course it's round. I just have a point to make that us down here.
No
in
more
Australia,
friendlies. Friendlies are forbidden. No more friendlies. If any more friendlies come up, I'm gonna kick you off immediately. I just kicked Jesus. Yes.
Hey there.
Resolution.
How are you?
How's it going? What shape do you think the Earth is?
Well, apparently the universe itself is flat, so that leads credence. Well, it leads credence to Earth being flat.
What shape do you think the Earth is?
Oh, damn it. I'm with the cube guy because of topology.
Get out of here. If we keep letting friendlies in, then the opposition won't come up. But honestly, if Alan was live on his TikTok, that's got to be really good advertisement for me. So, Alan, if any of your people are watching this, then by all means, send them over here. We can have a conversation. In fact, if you want to come back, we can have a conversation. But I didn't get your email, so kind of a bummer. Kind of a bummer. Yeah, so I mean, look, one of the easiest ways that we can figure out the shape of the Earth, or one of the easiest facts that we can demonstrate about the Earth, is that the Earth is in what's called a non-inertial reference frame. That's fairly easy to demonstrate in a number of ways. Maybe he did send it to the wrong email. It's drblitzphd@gmail.com. So if you sent it to doctor, like fully spelled out, then that would be the wrong place. But yeah, so you can just tell, you can tell that the Earth's in a non-inertial reference frame with 3 fairly straightforward experiments, none of which rely on the sky. And so that's pretty damning. We can also tell, for example, people went to Antarctica and witnessed a 24-hour sun. Like, that's a real thing. So there's a lot of evidences that point to the Earth being a globe. I mean, and then the fact that we have pictures of the Earth being a globe, obviously. And we have direct flights from Buenos Aires to Sydney. Johannesburg to Sydney. Like, we have these flights that on a planar Earth don't really work. Did Alan send you the email yet? He did not. I don't have anything yet. Did it go to my spam folder? Nope, didn't go to my spam folder. We should do a paper review when he does. Oh, that might be funny. Medical malpractice. Maybe medical malpractice can share his email. They seem to be on his nuts. Yeah, maybe you can. Medical malpractice. You should do that. Cartoon pics. What's your favorite Ghost album? Whichever one Cerise is on is really good. Thank you for the paper crane, Prosumo Boy Simon. It's either round horizon on a calm sea without elevation. You shouldn't be able to. Still did not email me. No. What if we're friendly but also flat earthers? Well, look, I have friends that are flat earthers, not like real life friends, but I'm friendly with people who are flat earthers. I just mean friendlies as in like people who are globe earthers. That's all. That's what I mean. Are black holes just dead ends in space-time? Maybe. Stay woke, bro. Still no email, I don't think. Yep, still no email. Bummer. What's on my shirt? It's a tardigrade. See? I want to hear from Flat Earth Raoul as well, but Flat Earth Raoul isn't interested in actually doing science, so... Ghost is Scooby-Doo metal. It's so true. Does he not just use the globe mail address? True. Can you explain the 24-hour sun? Yeah, so in the South Pole, because the Earth is on a tilt, sometimes that tilt would be pointed towards the sun. This is in the South Pole summer. And so because the Earth is tilted 23.5 degrees, there will be a part where the halfway line dividing day from night is because it's on the halfway line is straight up and down roughly, whereas the tilt is like this. So there will be some land that is always in day regardless of what time of the day it is, and so you can get a 24-hour sun. I'm a flat Earth conspiracy theorist, not a scientist. Well, why don't you tell me about your conspiracy theories? You should do that. You should respond to Kay's recent video about wavelengths. I feel like I should give her a rest because she's been through the ringer lately. Does it get exhausting hearing denial? Sometimes. When does the 24-hour sun happen in the South Pole? It happens in the Northern Hemisphere's winter months, like December, November, December, January. How do you have the patience for these people? I don't know. I taught engineers for a long time at university, and they're kind of crazy people too. Do you default to the scientific consensus when talking about a subject that's outside your field? Yeah, generally. I've spoken with Enoch. Yeah, I've spoken with Nathan several times. I don't know who Frederick is. But yeah, if you guys see any Flat Earth lives happening right now, feel free to have them come in and we can have a conversation. There are currently no guests in either TikTok or the YouTube box. If you're watching from YouTube and you want to join the conversation, just go to the link. Yeah, I don't have any guests because the flat earthers realized that, the Earth is a globe because the final experiment happened. Have I debated Caleb? You mean the neo-Nazi? I have, back before he revealed his true power and that he's actually a neo-Nazi. And then I stopped engaging with him because I don't engage with neo-Nazis. I mean, flat Earth, if I guess this means that the flat Earth truly is dead, if nobody can come up. Who would want to join with how you constantly interrupted Alan? Look, if Alan can talk without rambling, then I wouldn't have interrupted him. If he can say things that I don't already know, then I wouldn't have interrupted him. Fred's a creep. I thought Nathan was the guy who got caught at the elementary school. The Earth is, by the way, Dr. Blitz. Oh, well, that's cool. The live got recommended? Awesome. Do flat earthers still exist? Unfortunately, yeah. Yes, this will be live on this will be on YouTube after the live ends. Should you do mechanical or no, you should just do physics. Any person says that they want to be an engineer, should I do mechanical or electrical? Just do physics. Yeah, history is irrelevant for scientific experiments. No, just do physics, Ethan. It's so much easier that way. Alan repeated the same irrelevant nonsense too much, let it keep... Exactly, that's the point. No, it was super obvious, though. He was rambling about the history, which is irrelevant to the question. He was rambling about the relationship between the speed of light and celestial objects, which is irrelevant and also not true. It's just he couldn't get to the point. He couldn't actually get to the experiment that would demonstrate it. The null hypothesis might be that the Earth is a globe. The alternative hypothesis might be that the Earth is flat, and then you can make measurements, and you can make a prediction with your alternative hypothesis, and either the prediction comes true or it doesn't. And if it doesn't, then your alternative hypothesis is falsified. That's how that works. It makes predictions, and those predictions don't come true. That's what happened with the flat Earth. The flat Earth prediction, before everybody went to Antarctica, the flat Earth prediction was that there is no 24-hour sun in Antarctica. Then flat Earthers went to Antarctica, and they saw a 24-hour sun. And so the prediction was falsified, as was the model. Oh, we have a guest. Well, I don't know if it's a real guest, but Maybe the firmament was just painted a different color that day. So true. It was just painted sun color. Aim, how's it going?
Yeah, I'm good.
How old are you?
Nigger!
Imagine being that person. That's a child. His parents must have raised him poorly. Not all flat earthers predicted no 24-hour sun. I mean, the AE model predicts a 24-hour sun, or a no 24-hour sun, right? Like that's like the azimuthal equidistant projection map, which is a projection of the globe, by the way, predicts no 24-hour sun. The sun can't be visible for 24 hours in Antarctica without making your model ad hoc, right? It just doesn't work. But Medical Mastery, if you want to come up, the link's in the description, and it's also on the screen, so you can come up and we can talk about it. I need you? I don't need you for anything. In fact, I'd rather you all go away. King Drop, you can join the live just by clicking... Actually, let me just send you an invite. Oh, no, you're banned or something. Your life without us is boring as heck. No, I'm committed to... I have a very good life, thank you. But I appreciate you thinking that you matter. If that's your vibe, I guess. I want to listen to your debates with these flat earthers. No, I want to kick out the flat earthers. Not kick them out. Sorry, I want flat earthers to disappear. That'd be great. King Drop, I can't add you. It looks like you're banned or you turned off invites. All right, medical mastery. I promise I won't interrupt you. You want to come up? All right, we have Bo Jones. Bo Jones in the guest box. Let's bring him up. Bo, how's it going? What shape do you think the Earth is?
Pretty good. How are you?
I'm doing okay. What shape is the Earth?
You know what? I know it's not a ball.
Why do you say
it's
so?
Not a globe. None of the math actually matches up. If anything, if something that has to be so absolute can't have so many different views to it, you know, because it's absolute.
Sorry, what math doesn't
because
match up?
there's so much. Everything. Just
Can you give me an example?
The distance of the Earth.
So I can, you know.
Sure, like we can start with the curvature, saying 8 inches per mile, right? Which we really don't see that. It's not
So what does
observable.
that not match up with? What does
Well,
that not match up
that's the math of the data of what with observable reality.
So have you
In other
taken
words,
measurements?
70%. I mean, I don't think you have to take measurements. It should be up. It's something so absolute should be observable in actual reality.
The thing is like, if you want to say the math is wrong, like the math gives you a certain number for a certain amount of curvature, right? So if you want to say that number is wrong, you should go out and measure it and show that it's wrong. You can't just say it just feels wrong. That's not really good epistemological practices, right?
Well, I can relate to you in this way here. If we let's just say you go to your downtown and then you look at that building right in front of you and they said, hey, that building right there is 1,000 feet, right? Or something like that, or 100 feet, 10 stories high, something along the line of that. And then you'll look and you're like, you know what, observably, I can say that is true because it looks like that distance right there because I can compare it to something else.
But no, they could have been
Not
lying.
even
What if
that.
it's 100,
Not
what
even
if it's
that.
110,
But
what
you
if
can
it's
give a good
110
guess.
feet? What if it's 110 feet? Or what if it's 85 feet?
That's fine.
So you can't say that it's right.
It's within an no, because it's within that observable reality of margin of error, right? Which is probably like 1, 2, and I'll even extend it to like 3, 4%, bro. But when you're looking at something that's saying 8 inches per mile, and you go out into a flat plain area, I mean, just something with no buildings around, and I mean, really, if you just take a look from 180 degrees, turn from one side, look to the other side, dude, that's probably about like at least 5 miles, bro, and you should be able to see an observable curve. No?
So 5 miles is like 40 inch. What? It would be 25 squared. Well, so it's distance from you. So let's say it's 2 miles away from you on either side, just so the math is easier. So that would be 32 inches of drop, which is, you think that you can see something, you see, you think you can tell the difference of 32 inches over 2 miles away?
Observably, yes, you should be able to. That's
Actually,
a
I
significant
don't even
number
know if
which
I don't
you
even know if
should be
that's
able
true.
to tell.
What's the human eyesight angular? Let's just look up angular resolution of human eye. Let's just do, okay, so the angular resolution is about 1 arc minute, or about 0.017 degrees. So have you done the math to show that you can actually show that this is a thing?
Because what do you mean it's actually a thing? Something that's actually observable?
Yeah, to see if you should be able to see that. So, okay, so 0.017 degrees is how big the angle should be if you're able to see it. So we can just divide 32 inches by 2 miles. Let's open up a calculator. We're going to divide 32 inches by 5,280 divided by 12. And then we need to, that'll give us a number in radians. We need to multiply that by 180 and divide it by pi. And, oops, give me that number back. So, oops.
But bro, what I'm saying is that's,
Hold on. No, we're not done. You're not escaping the math. You're not escaping the math. So 32 inches, 32 inches,
you, dude. I like you.
32 inches is at the human angular resolution. So no, you wouldn't be able to see that.
Yeah.
You wouldn't be able to see it.
No, why not?
It's too small.
Why not?
Human eyes aren't that good.
I mean, that means the world is pretty damn big if that's the case.
The world is big,
it's not that 3,000.
No, 4,000 miles is, 4,000 mile radius is very big.
That.
4,000 miles is very big.
Yeah. And we also know the distance from here to, say, you know, from California to Boston or something. We know the distance from that. You know what I mean?
Like 3,000 miles or something
it doesn't visually connect. Right. I mean, you have to see some kind of. Second part, the world is 70% water, and absolutely, if water finds its level, then that means, damn, much of the Earth is probably almost level.
So do you think
and
that
the only curve that we see
is
is
on,
on land?
level?
30%.
Do you think that a water droplet sitting on your table is level?
Yeah, sure. I would have to say so.
Like
yeah,
the
or no?
The little half sphere is level.
Yeah. Okay, I can kind of understand that, dude. You can't say that, man, because that supports a flat Earth right there.
No, it doesn't. It says that water isn't always level.
Yeah. Because then you could say that it has that angular shape. I understand what you're saying. Dude. If you drop a water droplet right on a table, right, and then it'll form like almost like a dome shape, man.
Yeah. How does that? But that means that water isn't always level.
You're onto something there.
That means that water isn't always level, right?
Water isn't always level.
Right.
Water is level, and probably the bent to it is at the end.
Wait a minute. I'm sorry.
So maybe there's like a bowl right in the middle of it that's very, very, very big.
So water droplets, are they level or not?
Why don't you tell me, what do you think the water droplets are? They level or not?
They're obviously not level.
Because I've already told you,
they're shaped like half a sphere. They're shaped like half a sphere, so they're obviously not level.
Right.
Exactly. So water,
not even
half
a sphere, but less than half of a sphere.
So water is not level. It's not always level.
It's less than. So
why should I
water
believe that
will
that's true
not
about the Earth?
will not go into a ball.
Why not?
What's that?
Why not?
Because it's spinning at the same time too, and that water is just gonna. Right now, I could believe it if you say the raindrop as it comes down into that ball shape, right?
Wait,
but
why would it
static.
spinning stop the
It's
Earth?
not spinning.
Stop
It's
the
just
water
coming
from
down
sticking to the Earth? Why would the spinning stop that?
because it changes its shape when it spins. It changes its shape when it spins.
It does change its shape, so it's a little bit more bulged out at the equator than it is at the poles. But that wouldn't stop the water from sticking to the globe.
Yeah, but you don't. But you don't visually see that with any of the images that are provided.
You don't visually see what? You can literally see the curve of the
The
Earth
bulge in the
in
middle,
front of
as you
you
said.
on the ocean.
No, no way. Bro, I don't
What
see
do you
that.
think
I
what do
do
you think you're
apologize, but I do
what do you
not
think you're
see that.
seeing? What do you think you're seeing when say a cruise ship goes over the horizon? Why can't you see the cruise ship anymore?
Well, no. See, now you have to understand something is that I own a P1000 as well too.
Why
You can
can't you
definitely
see the
zoom
cruise
in
ship
and bring
anymore?
that back into.
You can do that for small ships. It never works for a cruise
Then
ship.
it has to be because perspective, the distance of my perspective.
What's stopping you from seeing
that
the
I
cruise
can
ship?
see? But if I had Superman eyes, I could probably.
What is
What's
stopping
that?
you from seeing the cruise ship?
What? I don't have Superman eyes.
Sorry, so there is light that's bouncing off the cruise ship, it going in all directions, right? That's how we see things, because, you know, if something is lit up by the sun, the sunlight will bounce off that thing, and then it'll get to your eyeballs, right? That's how you see it. Do we agree on that?
Sure, I can
Okay.
accept that.
So,
Yep, I agree with that.
The cruise ship is still lit up, right? And so, what is stopping the light from the cruise ship from getting to your eyeball?
There's a couple of things. Well, really, prospectively, the distance that I can see, the maximum distance that a human eye can see.
That doesn't answer my
Maybe
question.
if I had Superman eyes, I could still bring that shit back.
That doesn't answer
No,
my
go ahead.
question.
What do you mean?
Is there anything blocking the light from getting to your eyeballs?
You want me to say that the curvature of the Earth as it goes over, but that's what I'm saying is that
the light is going in all directions.
Yeah, if I had a P1,
The light is going in all directions.
sure, it's
right?
ominous.
Some of it
I
is
guess, right? But you can't.
If the Earth was flat, wouldn't some of that light be going to your eyeball?
Yes, and it does, and you can only see it for so much. Now, that's the big difference between the two models.
If it
is
gets
that
to your eyeball,
the
why can't you see
the
it?
heliocentric model believes that the sun is a lot bigger and farther away and more stronger, but the
Let's not talk
flat
about the
Earth
sun, we're
model,
talking about cruise ships.
it's believed that.
So
Okay.
if the Earth is flat, then the light can get from the cruise ship to your eyeball.
Uh-huh.
So why can't you see it?
Yes, it still could.
So why
Oh
can't
no,
you
because
see
you
it?
have to understand is if you look at your map right there, that cruise ship, if you're looking at there, but as it curves around the Earth, as the ship is moving around the Earth, right, it kind of curves, and you won't be able to see it anymore, though. That's the whole thing. Because you won't be able to see
I
that
thought the
far.
Earth was flat.
But if
I
you
thought the Earth
have
was flat.
Superman
Wait,
eyes,
where's the curve? Where's the curve? I thought the Earth was flat.
I don't. No, I'm talking about the turn, not the curve, but the turn. You know, in the circle
turn?
and stuff. But see, that's the whole
What
thing.
turn?
No one knows the shape of the Earth, man.
Yeah, we do. It's a globe.
Well, here, let me relative to a pizza, bro. Relative to a pizza. If you look in one direction, and as the ship moves around the water and stuff,
It's just
you won't be
going
able to see it
away from
anymore,
you.
man.
If it's
Too
going
far.
away from you, what stops the
Right.
light from getting to your eyeballs?
Sure.
Because if the light gets to your eyeballs, you should see it. That's what it means to see something.
Right.
So what
That's right.
stops the
That's
light
right.
from getting to your eyeballs?
If it gets
Because
to your
there's no-
eyeball.
yeah, so what stops it?
When the light is not strong enough to get to your eyeball anymore, I guess, right?
How does
If
the
it's not
light
strong enough to get your eyeball anymore, you won't be able to see it.
What do you mean by strong enough?
Distance plays a factor into it. Then, distance from you plays a factor into it because if
That just makes it appear smaller.
if something is sitting, yeah, to the point where you can't see it anymore.
But okay, so let's take your P1000, right? You zoom in on this cruise ship as it's
Sure.
disappearing. It's not disappearing into a
Right.
point. It will just get lower. It's not getting
Right, it
too
just
small to see
disappears to
because you
your
can see it
vision,
with
'cause you can
no even with a P1000, it doesn't shrink to a point like it's getting too far away. It just gets lower.
No, that's what I'm saying. Is
What do you
that
mean, no? We've all seen
with the
this.
P1 without the P1000. Hold on a second. Without the P1000, I can see a cruise ship, or let's just say a tanker. A cargo ship from a distance away to where it's like, oh yeah, you know what? Look, you can only see half of it right now. But then when you zoom in with the P1000, you can see all the way at the bottom of the water and everything.
You literally can see this with a P1000. Like, what's the... Like, you can see it just get lower, right?
Right.
Like, in fact, I'm
No,
pulling up
well,
a video.
with the P1000, as you zoom in with the P1000, you can actually see the bottom of the water in the ship. You have to do
No,
your own
but
research,
so
bro.
why can you only? I've literally seen videos of this. Why is it that you can only see the top half of the
Okay.
ship? Why can you only see the top half of the ship?
I think that's just the way how perspective works, man.
It's not how
You know,
perspective
with
works.
with the horizon of what you can see, your
It's not
eye
how
level of
perspective
horizon
works.
of what you can see. No.
No,
Okay.
it's not how perspective
Tell
works.
me.
Perspective works as if things get further away, they get smaller. That's what perspective is.
That's right.
That's all it is. That's all it is. It doesn't make things
That's right.
disappear bottom up first
Right.
or whatever.
Right. And you can only see the water for so far, which you could probably see the ship a little bit further, right? But then that's where it looks like it disappears below the horizon line. You know, and
So,
I'm just dude, I'm just
share
talking out of
something.
my ass, to be all honest with you, man.
I know,
Just
that's
because
okay.
none of us really know, man. None of us
We do
really
know. We do know. Don't worry. All right. So here's
No, we
video.
don't. We do know when I zoom in with my P1000 and bring it in.
Okay, so this is literally with this is with a Nikon Coolpix B700, but it's an extreme zoom lens, right? So we have cruise ship. You can see that blue stuff. See the blue stuff at the bottom?
Yep.
Okay, so we're gonna skip ahead. Well, we don't have to skip ahead. It's really, really shaky. Sorry. Come on, show us the other ship. Well, okay, we'll go back. We can go back here. I don't know if you can see it. Can you see the whole
Hey,
thing?
look, can I bring up a different topic or what? Can we bring up?
Well,
can we
no,
talk
no,
about something different then, or what? You want to talk about something different?
Why can't you see the blue things anymore in this
we can
picture?
stick with this.
Why can't you see the blue things anymore for this ship?
You haven't zoomed in. You haven't zoomed in farther enough. You need to zoom in a lot further.
This is a high zoom lens. This is another Nikon.
No, you need the P1000. The P1000 brings magical features into this world.
Oh, so the P1000 is magic. Got it. It lets you see over the curvature. You guys heard
Yeah,
it? You guys heard
it must be.
Right. Nikon P1000.
You can see over this curvature. So
here's one.
So if you
here's one with
can,
Nikon
I have a
2000.
question. I have a question. So if you really think, if you think we live on a ball, right? If you think we live in a ball and we spin in one direction, right? And sometimes it wobbles and stuff. So that means we have a North Pole, right? Which is where the the North Pole is at, right at the top.
Yes, we have a North Pole.
So then we should only have one consistent South Pole then, right?
Yeah, well, yeah. Or if you're talking about the magnetic north and magnetic south, those move. But the geographic north and geographic south, those are in one place. Yeah.
No, why don't you look it up? Look it up. Look it up how many South Poles we have.
Are you talking about the geographic South Pole or the magnetic South Pole?
Just look up how many South Poles we have.
Can you answer my question, please?
I'm not gonna.
Which
I
one
don't
is
know. On a flat Earth map, there is no South Pole, dude.
I'm
So
aware.
I'm asking you on your model.
which one do you
Just
want me to
Google
look
up
up?
how many South Poles do we have.
Well, there's two types of.
Look up the
Actually, I
one
guess
you
there's
wanna
a
look
third.
up, bro. You tell me.
Okay, so let's just type it in. How many South
There's like
Poles do
multiple
we
South
have?
Poles, man. Yeah, there are many.
Yeah. This is exactly what I said.
Explain that.
This is exactly what I said. So there are, in fact, there are three.
Why are there many
There
South
is the
Poles, man?
I'm literally answering you. Please don't interrupt. There are three. There is the
Oh, my bad.
geographic.
Sorry about that.
There is the geographic South Pole. There is the magnetic South Pole. And then there is the ceremonial South Pole, which has been set aside for photo opportunities. So there are three, according to National Geographic. And I told you the magnetic South Pole does.
There
move,
you go.
the
There's
geographic
multiple South Poles.
doesn't.
How is that possible?
I explained this to you already, but you might be.
No,
maybe
you got to
weren't
look it
listening.
up.
I explained this to you already. Maybe you weren't listening. The
I'm
geographic
listening
South
to
Pole.
you.
The geographic
I'm
South Pole is
listening.
the geographic South Pole is the bottom of the Earth. That's the one that doesn't move. The magnetic South Pole isn't related. I mean, it's closely related, but it's not the same place as the geographic South Pole. The magnetic South Pole is just where compasses point. Compasses don't point to the geographic South Pole, the axis of rotation. They point to where the magnetic fields go in. So I don't see what your issue is.
No, I do. You're not. You totally made that
What's the
stuff
issue?
up, man.
No, I just read it
it's
from
okay,
National
man.
Geographic.
It's okay. There's no. I don't have an issue. I will
I mean, you're
never
being
have an
wildly
issue, man.
dishonest,
Like I said,
so-
we're just
so
here
it's okay.
discussing.
You're being wildly dishonest. at this
How
point.
am I being dishonest? What did I
You
say?
just
was
said it. You just said I
dishonest?
made that stuff up.
Huh?
That's pretty dishonest of you.
I didn't make that stuff up.
You said I made
I didn't
it
say
up,
I made
and that's
anything up.
dishonest. You
Oh,
said
no,
I
I'm
made it
saying.
up.
Well, well, you definitely put it to a way to which it benefited your argument, which is cool. Very clever.
Yes,
That's
it
very clever,
does
man.
because the
I'm
Earth is
very
a
impressed with
globe,
that.
and facts benefit my argument.
Right.
That's true. So did you understand what I said? Can
No
you repeat
problem.
it back to me?
Well, then absolutely no problem. I'm willing to accept that, dude. I'm not arguing against you. Okay, I'm not arguing. So then, if that's true, then how is it that the flights are so, you know what I mean, reflects off of what a model of flat Earth is?
They don't.
Why is that?
Flat Earth
They
can't
do.
account for direct
I'll-
flights from Sydney to Johannesburg.
Oh wait, okay. And how many flights do they fly from there to there, and how far of a flight? Look it up. There's only like one airliner
Yeah.
that does it, which is
Yeah,
the
yeah.
Dreamliner, which really just came about just for those long
Qantas.
trips.
It's Qantas.
But
Yeah, yeah.
on your ball model, it's not that far. It's like less than from here to
It's
you
still
know
pretty far.
what you call, man.
Continent,
Probably
right?
how far is it, dude? How far is it on the globe model as
Or
opposed
maybe,
to that?
is it Perth? Yeah, no, it's SYD to JNP, so SYD to JNB flight. So it is a 14-hour and 40-minute flight. So it's a long international flight, but like
Woo, man, how is
14 hours.
How is that a 14-hour flight? And when
Because
you look
they're
at
far
it
away
on
from-
a ball,
on a globe, they're still
it's
pretty
not
far
that
from each
far.
other. It is pretty far.
Mm.
I don't know why you think it's not. We can even look this up. Distance from Johannesburg to Sydney. It's 11,000 kilometers.
So
which is pretty far.
Yeah, it's pretty far.
So now, how
Doesn't
far would
that
that be on a
reflect
flat
on
Earth?
like a flat Earth as well?
How
too?
far
It's
would
pretty far.
no? How far would that be on a flat Earth? Do you
I think that's same thing.
No, it'd be like
Same thing.
three times. It'd be like 3 times.
I don't
the distance.
think. No, on the globe it's not that far. It should be pretty close, man.
So we can just check this.
I mean, from
okay?
the model that I've seen on the ball,
we can just check this.
on the globes that I've seen.
You've seen wrong. Let's just check this. We're just gonna do the math. It'll be fine. All right.
Sure, let's always resort to the math. The math
You
will
were the
always
one who said that the
escape
math
from
doesn't
any
work,
type
right?
of realistic arguments.
Okay. Here's your flat Earth, right?
Yeah, it does. It doesn't work with the ball model, but we
So
can
here's
go
your-
with the math because that's always the final argument.
Yes,
that
because
Globers
math
will
is
always
objective, right?
Result.
So, Bo,
Oh, the math. Let's
Bo.
go to the math. Well,
So-
bro, the math doesn't matches the
Hey, Bo,
realistic.
quit crying.
You know,
and
the
let's talk.
reality of it.
Okay, I'm gonna mute you. So the distance from the direct line distance from Antarctica to from Sydney to Johannesburg is about twice the distance from Sydney to, say, Delhi. So we can look up the distance from Sydney to Delhi. Or actually, let's just look up flights. Sydney to Delhi flights. Okay? So a flight from Sydney to Delhi is going to take. So this is these are just flights. That has a connection in Singapore. We want to direct. Are there any flights from Australia to, say, we can say, why not Qatar? So flight from Doha to Sydney. I think that there are direct flights. Perfect. Qatar Airways 908, right? So that is a 14-hour flight. It's a 14-hour flight from Qatar to Sydney. Now, what about from Qatar to Johannesburg? Johannesburg. Flight time. That's a 14-hour flight. That's another 8 hours. So on a flat Earth map, you can unmute yourself, by the way. On a flat Earth map, if you were to travel directly from Sydney to Johannesburg, which is, you'd have to fly over Qatar, that would take at least 22 hours, the direct flight. But somehow it only takes 14 hours. How does that work?
It's the Dreamliner. It's the new type of airliner that goes faster and farther and stuff.
We can look up the speed of the Dreamliner.
It's a different type of airliner.
Speed
than
of
the other ones,
Dreamliner.
too. Yeah, look it up.
956 kilometers per hour. Which is basically the same flight, and actually, I think that we can just double check what plane this is on. The flights that I was referencing are on Airbus A388. So let's look up A388 top speed.
No, look, it's a Dreamliner. It's a Dreamliner.
No. So
Dreamliner.
the flight that I was talking about was the flight from Sydney to Qatar, 14 hours. That can reach, let's see, Mach 0.88. So Mach 0.88, 2 kilometers per hour, is one. In fact, the flight that takes you from Sydney to Qatar in 14 hours flies faster than the Dreamliner. It's about 1,000. It's about 1,000 or 100 kilometers an hour faster. So, it flies faster, and it goes a shorter distance in the same amount of time. Make that make sense, or maybe the flat Earth just isn't right. You there?
No, I'm here. Like I said, your math is always going to math up to whatever the globe model is, but in reality, that never came about. This I'm done arguing with
bro,
this.
We didn't do any math. All we did was we compared flight times. The flight time from Sydney to Qatar. Do you know where those are? Do you know where those places are?
Yep.
Okay, so on your flat Earth, if you want to go from Sydney to Qatar, or if you want to go from Sydney to Johannesburg, you would have to fly over Qatar, right?
Yeah, man, I guess so.
And the flight from Sydney to Qatar is 14 hours. And the flight from Sydney to Johannesburg is also 14 hours. So how is it that it takes the same amount of time to get to Qatar? Do they just teleport to Johannesburg after getting to Qatar?
I don't know, man. I wouldn't know. To be honest,
All
I
right,
don't think any of us really knows.
We do. But thanks for being here. You don't sound like you're interested in having a conversation. So we're going to bring up a guest from YouTube. Piezo, how's it going? Sorry to keep you waiting. Can you hear me all right? I can. Let me connect you to... let me make sure that people can see your little icon. Phenomena. One sec. Video settings. Where's the settings? I want to give you a default icon. All right, can everybody hear him on YouTube and on TikTok? Go ahead and give us some words there, Piezo. All right, we can hear you. I think we're good. So what's up? What shape do you think the Earth is? Okay. Facts? I agree. We can talk about them. Why don't we... I mean, either one's fine. I think that it's probably easier to measure motion without worrying about, like, refraction and stuff. So why don't we talk about motion? Mm-hmm. I have, yeah. I think because you guys think that there's an ether. Well, it would, right? Like, if there's an ether and the Earth was moving through it and had an ether wind, then Airy should have detected some deviation. But he didn't detect deviation. But that's because there's no ether. You wouldn't there would be no ether drag if there's no ether, so you wouldn't expect it. But why don't we actually talk about something easier? Why don't we just talk about something that's easier to measure, like the motion, like the Earth's rotation? Sure. So why are we talking about something that's much, much harder to measure when we could just talk about the rotation of the Earth? Why don't we just talk about the rotation of the Earth? No, I want to talk about the rotation of the Earth. What's rotating? Oh, hold on. People can't hear you on YouTube. I don't know. One sec. Hold on, one sec. Oh, I'm stupid. I'm sorry, one moment. I'm so dumb. I'm sorry. Should be able to see you. It should be good now. Say something?
Can you hear me now?
Yeah, I think so.
Okay. So basically what I was saying is when you talk about rotation, there's definitely a rotation.
What's rotating?
But it goes to, it'll be a lot longer of a, well, my position would be that there is a...
So what's actually rotating? And I'm not talking about propagation of light, by the way. I'm just asking, like, we're not talking about light at all.
But once again, like that'll take us into a whole host of things, you know, MMX.
No, that's all about the orbit. I'm talking about the rotational motion of the Earth.
No, it's commensurate with
Can you account for the Compton?
It's important in talking about rotation.
The Compton generator.
The Compton effect.
It's a small device.
I think we're bouncing.
No, it's a small device that is used to measure the rotation of the Earth about its axis.
No, but just to be clear, you don't.
I'm not talking about ether. I'm not talking about. So a Compton generator has nothing to do with light, by the way. So the ether, none of this stuff is relevant.
Can we just get on?
Yeah, we are. We're talking about a Compton generator. We're talking about the rotation of the Earth. We're not talking about MMX. We're not talking about the orbit of the Earth. We're talking about...
Why is it mutually exclusive to a rotating Earth?
Well, unless you can produce some account for why fluid starts to spin when you flip it over, like why it starts to rotate around some central axis when you flip it, then
it starts to rotate around an axis.
So I'll explain the experiment. You take a circular tube, fill it with water. You place it on a table, let it come to rest, right? Then you just flip it over on its side. So you're not flipping it in a way that would induce rotation. You're not like spinning it. You're just flipping it, right? But when you do so, the water starts to circulate through the tube, and it circulates in a direction that depends on your latitude. Sorry, it circulates in a direction at a speed that depends on your latitude. Do you have an explanation for this on a flat Earth?
Oh, that's fine. It would be the same explanation as we use for anything else that has a latitude dependent.
Okay, what's the explanation?
Component.
What's the explanation?
There's an ether wind, bro. And depending upon where you are.
Why is ether affecting the motion of water?
It affects the motion of all objects. It does the same thing with pendulums.
Oh, okay. So how does that function? What is the interaction there?
There's a greater velocity at the outer latitude than there is at the inner latitude, which causes a greater momentum at that particular portion of the object, which causes a preferred bias in the rotation.
No, I'm asking what's the interaction? What causes? What actually, like, the ether is a thing in your view. The water is a thing. How does the ether interact with the water?
How does it interact with the water?
Yes.
It's present in all matter. But, I mean, I just really wanted to, I came in here to talk about these two things.
We're talking about the motion of the Earth.
Thing. Yeah, but you kind of like jumped off of airy and.
Well, yeah, I don't care about airy.
Isn't that
because
literally
it's not really relevant. Like with airy, you have to distinguish between ether models and which can be fairly complicated and non-etheric models. But we have mechanisms to measuring the shape of, or measuring the rotation of the Earth that doesn't rely on light whatsoever.
The sky rotates and translates motion to us, like with or without an ether.
Why does the direction of rotation change whether you're north or south of the equator then?
Why does the direction?
Why does the ether wind spin in a different direction when you're on one side of the equator as opposed to the other side?
Oh, because we live in a toroidal geometry of the ether flow. So like the magnetic field of Earth is a toroidal field. So it causes a flow that follows that geometry.
Tell me what you think a toroidal field is.
What do I think? I mean, do you want to
what
pull
do you
up a
think
diagram of a toroid?
Yeah, so a toroid
you can model it pretty easy with a dipole magnet.
So
if you use a dipole magnet.
To be clear, you're thinking of a poloidal field, not a toroidal field. Flat earthers tend to get this wrong. The poloidal field is the one that looks like an apple, not a toroidal field.
No, like if you take a dipole magnet, it generates a toroidal field.
No, it generates a poloidal field.
We're talking about a hypertrochoid and a toroid.
A toroidal field is the magnetic field inside a toroidal solenoid.
Yeah. Okay. Anyways, so
what's the source of this magnetic field?
The source of it? Not sure. Yeah. That's immaterial. We know that we have one. I mean,
how do you know?
In your model, we can measure it.
Yeah, but sorry. So the direction points in the same direction, north or south of the equator. I know your position is that the Earth is flat.
Yeah, but I'm trying to, present information to support my position. I haven't been able to do so because you're kind of scattergunning like 70 questions right now.
I brought up one thing. You wanted to talk about the shape, the motion of the Earth, so I brought up a Compton generator, which demonstrates the motion of the Earth.
Is it cool if I give my position for 2 minutes uninterrupted and then
sure, if you want, you can read your script if you want. Sure.
Okay, it's not a script, but I appreciate it. Okay, so just to be clear, right? We all agree that stellar aberration exists, right?
Sure.
So since stellar aberration is a true thing, then the claim becomes, what is its cause? Okay, what is the cause of stellar aberration? Now, if you go to Wikipedia or any physics textbook, you can go to the free LibreText online, whichever one you want to use. Mm-hmm. They will all tell you that it's a product of the ratio of the velocities between the motion of the Earth as it translates itself through space and that of light. Okay, when light enters the telescope, the Earth is said to be moving horizontally underneath it, so that during the time of flight that it takes the light to move through the telescope, the Earth literally shifts out from underneath the light, which is what causes one to have to tilt it to keep the light centered, the star centered inside the telescope. We agree, and we're all in agreement about that part.
That's roughly
not like
right.
That's not the controversial part. So where
we agree that would happen if the Earth was moving, right?
Yeah, of course.
Okay, sure, go ahead.
Of course. And so then the positive claim, you have a positive claim in your paradigm of motion, right? So you have to have a way to test, right, to test that specific part. So the way that you would do this is you would say, okay, what is the formula to calculate stellar aberration? This 20.5 degrees roughly that we get for about almost every star, how do we get that?
20.5 degrees? It's not 20.5 degrees.
Arc seconds. Arc seconds.
Sure.
20.5 arc seconds. So we have tangent theta equals V over C, or you can use the relativistic formula. Degrees down to like 2/10 millionths of a degree. It's the same. All intents and purposes, it's the same. So the only two variables that we have, there's literally only two, are V and C. V is that of Earth, C is that of light moving through the telescope. Well, since we can't change the Earth's speed if it was moving, the only thing that we can change is the velocity of light. So when you put a medium inside your telescope, such as water, for example, it will slow the light down, causing that C component to now be 0.75 C in the case of water. So since the light is moving at 3/4 its original speed, the angle should become 4/3 the original angle. And
so now, my understanding of Airy's experiment is that they expected a difference after accounting for refraction, which is what you're describing. You're describing refraction, but they didn't detect a difference after accounting for refraction. Which means that they accounted for refraction, i.e., the change in speed of light. That's what refraction is.
Well, refraction has a different cause than aberration. Aberration is specifically about the ratio of the velocities. Refraction is
Where
about
do you think
a
that
medium
ratio
interface.
comes from?
So let me ask you a question. This is why
Sure.
I believe you're wrong.
Okay.
You're telling me that light entering a stationary bucket of water and light entering a moving bucket of water would be viewed at the same angle through a lens on the other end?
Sorry, one sec. My mouse stopped working. One more time.
If I took a bucket of water and I put a lens on the end of it and I shot a laser through it, right?
Mm-hmm.
Or let's say that I was able to slow the laser down super, super slow so we could see it in like human, human perception, right?
Sure.
You think that shooting it through the bucket with water in it, as the bucket is stationary, and shooting it through the bucket while the bucket is moving would cause the laser to land in the same position on the other end?
Well, you'd have to account for refraction, right?
Sure, but if we represent the laser as a marble that still obeys all the laws of light, just a marble so we can visualize it easily, right?
But the thing is it's not a marble, right? Light is not a marble. It's a wave that is moving at a constant speed in all reference frames. That's the point.
Okay, sure. But
by the way, I have 7 minutes left, just letting you know. So I don't dip you because I have a meeting. Go ahead.
But see, Fizeau, if you claim it's a wave, we know that Fresnel drag proves that there is a proportional velocity component of a certain percentage of the velocity of a medium in motion that's carried and applied to the light that moves through it.
You'd have to be more specific. That was super vague. Or was at least hard to understand what you were saying.
Fresnel drag, okay. He proposed a formula in 1818, I want to say, based on the refractive index of a material being proportional to the compressibility of ether in that material, and he predicted what the speed of light would be moving through a material. And it, to this day, is actually 100% precisely correct. It was demonstrated in 1851 by Fizeau. He shot 2 coherent light sources through an interferometer made of water streams. The water's all flowing in the same direction. But then the light takes 2 different paths through it. So in one path, it goes along with the water, and the other path, it goes against the water. And he found that the water transmitted 44% of its velocity to the light. So
that's exactly. Wait, hold on. That's exactly what's expected under relativity.
They tried to use a relativistic derivation later, but the problem is you can't. I mean, Michelson referred to it even in the Michelson-Morley experiment in 1887.
No, it's literally derivable from relativity.
No, I get it, but you would have to, in order for Fresnel drag, right, mechanistically to be accounted for in Airy's experiment, you would literally have to have the wave being carried in the opposite direction of the motion in order to make up for the expected angle change. And that's absolutely preposterous. In page 1 of MMX's
I haven't heard that
original
claim.
paper,
I'm not sure if that's true.
Yeah, read 1887, Michelson-Morley's original paper.
I've read Michelson-Morley's original paper.
Page 1, he refers to this. And he refers to how both the ballistic theory of light, like the photon theory, the emission theory, as well as the undulatory theory, the wave theory, both of them have a problem explaining this, but the emission theory is even worse.
Explaining what?
Explaining the results of Airy's experiment.
All right, we can pull up Michelson-Morley's experiment. Or Michelson-Morley paper. The 1887 one, yeah?
Yeah.
Page 1.
Yep.
The discovery of the aberration of light was soon followed by an explanation according to the emission theory. The effect was attributed to a simple composition of the velocity of light with the velocity of the Earth in its orbit. That's a mistake. The difficulties in this apparently sufficient explanation were overlooked until an explanation of the undulatory theory of light was proposed. This new explanation was at first almost as simple as the former, but it failed to account for the fact proved by an experiment that the aberration was unchanged when observations were made with a telescope filled with water. For if the tangent of the angle of the aberration is the ratio of the velocity of the Earth to the velocity of light, then, since the latter velocity in water is 3/4 its velocity in vacuum, the aberration is observed with a water telescope should be 4/3 of its true value. Yeah, so is your claim that they didn't have to account for any refractive effects?
Say that one more time.
Is your claim that they didn't have to account for any refractive effects in the Airy experiment?
No.
Your
No,
claim is
that's
that
not
is
what I'm
that
saying.
it lands. Okay, so they did have to
please
account
read
for
the
a refractive
footnote.
effect.
Please
Yeah.
read
So
the
the footnote says it may be noticed that most writers admit the sufficiency of the explanation according to the emission of light, while in fact the difficulty is even greater than according to the undulatory theory of light. For on the emission theory, the velocity of light must be greater in the water telescope, and therefore the angle of aberration should be less. Hence, in order to reduce it to its true value, we must make the absurd hypothesis the motion of water in the telescope carries a ray of light in the opposite direction. That's fine. Using the emission theory of light, where you assume that the velocity of light is added the velocity of Earth in its orbit, but that's just not true. Right? That's just a false assumption. So of course, if you make a false assumption that the velocities just add, that light is faster relative to the Earth than it is relative to some stationary ether, then of course you're going to get the wrong answer.
Okay, but see,
it's just like trivially not true. Like, of course they got it wrong. They didn't know about relativity yet.
Relativity doesn't explain it. It predicts the same angle that
relativity,
the classical formula does.
The claim that you made that according to ether that it wasn't that the emission theory wasn't able to account for Airy's result relies on the assumption that the speed of light varies depending on what reference frame you're in. But if you throw that assumption out because it's false, it does really. The speed of light varies depending on your reference frame.
Yeah,
where's the experiment?
It's
Go win your Nobel Prize.
Hold on. It's slower in. I'll give you two examples. One, I'll explain it.
By the way, we're talking about the speed of light in a vacuum, to be clear.
Okay, but check this out. Are you saying in the frame of the water, right? I'm in the frame of the water.
Mm-hmm.
If I'm an observer in the frame of the water, when I measure the light in the water, what speed do I measure it as? C
so you will. So
C?
if you're in water, you will measure the light moving at 3/4 the speed of light in a vacuum because that's the refractive index of water.
Okay, so do you know about the Sagnac effect then? Because
I do know about the Sagnac effect. Yeah.
It literally shows that the speed of light's not constant. It's C plus or minus
It literally
B.
No. That's it. Literally doesn't show that. It shows that the trajectory
That's how all interferometry
that a
works.
light beam. It literally shows that the trajectory of a light beam in a closed circuit might have a larger space-time interval in one direction than in another direction, depending on the circuit that it's taking. I can link you. I can reference a paper for you if you want, so you can go read about it.
Sure. So from the frame, from the frame.
Let me see one second. Let me pull it up. I have it somewhere. Come on.
How can you have different space-time intervals if you have to maintain Lorentz symmetry on your table?
The space-time intervals are different because the starting and ending points are different. Here's the paper.
So here's a really simple question. Is
this the one that I want? Yeah, this is the one that I want.
When you talk about the Sagnac effect, right? We know that what the starting and ending points are. It's the emitter and the detector, right? Okay. But the emitter and detector are the start and end points, right?
Yep.
So it starts at the okay. So we'll just use the detector since that's the observer. The detector and the observer are synonymous here. You're an observer, you're a detector. And in the lab, of course, the table's rotating, but in the frame of the table, the world's spinning around it, right?
Sure.
Okay. So on the table.
Wait, sorry. Actually, repeat that last statement. I'm not sure I agree.
As an
I'll let you have the last word, but I have to run because I have that meeting that I mentioned 7 minutes ago. So you can have the last word if you want.
Okay. As an inertial observer on the table, you're just stationary on the table. You're the detector, right? You're receiving this light beam from the emitter. It's coming towards you. You see the world spinning around you, right? That's what you see as an observer on the table. With respect to what are you able to measure a fringe shift? Because the gap, the length between the emitter and the detector in your frame never change. There's never a change in path length at any moment. There's always a constant distance between the emitter and detector. And so from the frame of the table where the effect is actually measured, there's no way under relativity to
I suggest you read this paper. It'll explain how you can derive it using relativity. But I gotta run. Any final words before I end it here?
C plus or minus B solves it. Yeah.
Any last words?
Yes, in Sagnac's original work, right? He perfectly predicts it and models it. Used experiment and mounted the emitter and detector to a wall, and then put mirrors on a rotating table and spun it and got the same exact result with the mirror and detector, or with the emitter and detector mounted table. So in either frame, in the lab frame or in the table frame, both were shown to be perfectly equivalent, C plus or minus V of the table with respect to the lab, which shows that the lab frame is the preferred frame.
I gotta let you go.
Based on a square.
I gotta let you go, but go read this paper. It derives it using relativity. Thanks for being here. All right, y'all. I gotta run, unfortunately. I do have a meeting. I know that usually my lives go later, but I have a meeting, so I will see you guys. Don't mind that. I will see you guys next time. tomorrow around the same time. Take care, everybody.